Welcome to the Sleepy Cosmos channel, a place where science and serenity meet. Here we explore the quiet wonders of the universe, from dark matter to string theory, all told in a calm, soothing rhythm designed to help you relax, drift, and dream among the stars. Each video is a guided journey through the cosmos, slow, meditative, and filled with real science wrapped in gentle storytelling. So if you love space, curiosity, and the peaceful side of knowledge, you're in the right place. Make sure to subscribe for more new sleep narrations every week. And if you'd like to reach out for collaborations or business inquiries, you can contact us at the sleepycosmoschannel@gmail.com. Now, settle in, take a deep breath, and let's drift into the universe together. Close your eyes and let the universe begin to hum. Not loud, not sudden, just a quiet resonance beneath thought, a vibration that feels more like memory than sound. The air around you is calm, but deep beneath it, beneath the silence itself, there is motion. Everything that exists moves. Every grain of dust, every atom, every unseen particle is trembling, softly, constantly, a song played by reality itself. You may not hear it, but you are part of it. Your heartbeat, your breath, the hum of your own body are harmonies of the same cosmic orchestra. And the further we look into the depths of physics, the clearer it becomes. The universe is not built from stillness, but from rhythm. It is not made of points and pieces, but of pulses and patterns. A grand composition written across time and space. For a long time, scientists believed the world was made of tiny points, indivisible particles, the ultimate little building blocks of everything. But the mathematics of those points was sharp and unkind. When physicists tried to unite the quantum laws of the small with Einstein's smooth geometry of the large, their equations exploded into infinities. Reality, it seemed, refused to be described by points alone. So a gentler idea appeared. What if the smallest things in the universe weren't points, but strings? Tiny threads of energy, vibrating in countless patterns, so small that even a single atom would be a continent beside them. These strings could stretch, loop, and resonate, and in their motion lay the key to everything. When a string vibrates one way, it becomes what we call an electron. When it vibrates another, it becomes light. Another pattern, and it may carry the whisper of gravity itself. All the particles, all the forces, the universe's entire vocabulary, arising not from different substances, but from different songs. Every vibration is a note, every note a particle, every particle a melody in the great composition of being. You, the listener, are built from these same notes. The table beside you, the stars overhead, the space between them, all of it made from the same universal rhythm. What we call matter is simply organized music. What we call energy is how loudly the universe sings. Think of a violin string. When you pluck it softly, you hear one clear tone. But if you listen closely, you realize that tone is made of many smaller harmonics, waves within waves, each one shaping the final sound. Now imagine such a string so small you could never see it. It hums not in air, but in the fabric of space-time itself. Its vibrations ripple through dimensions, and every possible pattern creates something different: a photon, a quark, a neutrino, a graviton. Reality is not built from objects. It is built from frequencies, from patterns of motion too small to see, but too powerful to stop. In the language of physics, this is called string theory. But tonight, you don't need the equations or the formal names. You only need the feeling that somewhere beneath everything, the universe is humming. Every cell in your body vibrates with it. Every atom, every particle plays its part in the quiet symphony of existence. Even empty space is not empty. It too vibrates. Quantum fields fluctuate even in the vacuum, giving rise to what physicists call zero-point energy, a restless hum that never ceases, even when the temperature drops to absolute zero. Perfect stillness is impossible. The music never ends. If you could somehow hear this music, if your ears could perceive what your mind can only imagine, you would hear a sound too vast for words, a sound not made of air, but of being. You would hear gravity's soft pull, woven with the light of stars. You would hear the rise and fall of space-time itself, a gentle breathing of the cosmos, and within it, your heartbeat would match the rhythm. Because you are not separate from this song. You are made of it. You are one of its verses. Every person who has ever looked up at the night sky has felt this. even without knowing the physics. The sense that something greater is moving invisibly, eternally, that all of existence is connected through an unseen pulse. String theory gives language to that feeling. It says, yes, there is connection. Yes, there is motion beneath the silence. The universe is not static. It is alive with vibration, and every vibration carries meaning. Somewhere in those trembling threads is the reason the electron has its charge, the reason light travels at the speed it does, the reason gravity stretches across galaxies. Each property of nature is a musical note of the underlying strings. Now breathe deeply and imagine space itself as an ocean. Its waves rise and fall, creating ripples that we call particles. But beneath those waves, the strings dance. Tiny filaments of energy, curving and folding, playing the music of reality. You could spend a lifetime studying their harmonies and still not hear the whole song. Because this symphony is infinite. Every atom in your body contains a hidden orchestra. Every spark of light from a distant galaxy is another phrase of the same composition. And all of it plays together, without conductor, without beginning, without end. If there is a word for such unity, it is harmony. The forces that govern the universe, electromagnetism, gravity, the strong and weak nuclear forces, are not strangers. They are instruments in the same orchestra. Different sections, different voices, but the same score. Physicists have long sought to find a single theory that explains them all, a theory of everything. And string theory, with its elegant mathematics and its musical heart, may be the closest melody yet. But the music of the universe is not something to solve. It is something to listen to. Each discovery, each new equation or observation is like uncovering a few more bars of the cosmic sheet music. And the more we uncover, the more we realize how vast the song truly is. Somewhere within its chords lie the mysteries of dark matter, dark energy, and the hidden dimensions beyond our sight. Each mystery is a note not yet resolved, a melody still unfolding, and like a lullaby, it invites you not to rush for answers, but to rest within the wonder. Because wonder is the universe recognizing itself in you. You, the listener, are the consciousness through which the cosmos becomes aware of its own sound. The universe sings, and through you it hears itself. So let the day fall away. Let the mind grow quiet. Breathe in the soft hum beneath existence. Breathe out the noise that hides it. The strings are still vibrating, their music endless, their rhythm older than time. And as you drift deeper into the sound, you will find that peace is not the absence of motion, but the perfect harmony of it. Welcome to the universe as music. Welcome to the first note of the dream. Close your eyes and imagine the smallest thing you can. Smaller than a cell, smaller than an atom, smaller than the nucleus within the atom. Keep going until the very idea of size begins to dissolve. Here, in this invisible realm, our familiar picture of matter breaks apart. The laws that guide the large and the laws that govern the small refuse to speak the same language. Quantum mechanics tells us that everything exists as waves of probability, that particles do not have fixed positions until they are observed. General relativity tells us that gravity is not a force at all, but the bending of space and time themselves. Each of these ideas is precise and successful within its own world, but when we try to merge them, the mathematics collapses. The equations explode into infinities, numbers that stretch beyond meaning. Something essential is missing, something smoother than the picture of tiny, solid dots. For decades, physicists imagined that the universe was built from point-like particles, dimensionless specks of energy, each occupying a single location in space. It seemed simple, but it was too sharp. When these points were forced to interact, the mathematics became violent. The closer they came together, the higher the energy density became, until it reached infinity. Infinity is nature's way of saying wrong description. So the search began for a gentler model, something that could soften the edges of the universe. And from that search, a new idea was born. What if the basic ingredients of reality are not points, but strings? Not dots of zero size, but tiny one-dimensional filaments, each capable of vibrating. A string is not made of anything smaller. It is energy itself, stretched into a line. Its length is unimaginably short, around 10 to the power of minus 35 meters, the scale known as the Planck length. At that depth, space and time themselves begin to shimmer. Geometry loses its clarity. The idea of position becomes uncertain. Within that trembling fabric, the string moves and resonates, not through empty space, but through a fluctuating sea of energy, a quantum ocean that is never still. This single change, from points to strings, reshapes everything. Collisions no longer happen at a single point, but along a short stretch of the string's length. Energy spreads gently, infinities vanish, and the mathematics becomes calm again. It is as if nature prefers curves to corners, vibration to impact, music to noise. Every string can vibrate in countless ways. It can twist, loop, stretch, or oscillate gently. Each mode of vibration creates a different kind of particle. One pattern becomes an electron, another pattern becomes light, another may carry the whisper of gravity itself. The entire zoo of particles is nothing more than the repertoire of the string's song. The universe, then, is not made of many kinds of substance, but of one universal filament, playing itself in infinite variations. Just as a violin string can produce many notes, the cosmic string produces the symphony of existence. Matter and energy are not different things. They are different melodies. Each vibration defines its own identity. Frequency determines energy. Energy determines mass. In the simplest words, how a string vibrates decides what it becomes. Fast vibrations create heavy particles. Slower ones create lighter particles. Every particle's nature, its charge, its spin, its mass, is encoded in its rhythm. To imagine this, think of plucking a guitar string. When it vibrates as a whole, you hear the fundamental tone. But if it vibrates in halves, thirds, or quarters, you hear overtones, harmonics, each one adding depth to the sound. The universe operates on the same principle. Each fundamental string vibrates in multiple harmonic modes at once, producing the spectrum of matter that builds the world. What we perceive as an electron, a photon, or a graviton is simply a particular standing wave within the grand instrument of reality. At the Planck scale, this vibration replaces the notion of structure. There are no smaller pieces. Space itself cannot be divided further. Try to look closer, and you would need so much energy that it would collapse the region into a black hole. Nature draws a quiet limit, a boundary beneath which measurement has no meaning. The Planck length is that boundary. Strings fit perfectly within it. They are the smallest meaningful motions the universe allows. Among their infinite patterns, one vibration stands out. When a string moves in a particular symmetrical way, it produces a particle with 0 mass and 2 units of intrinsic spin. This matches the description of the graviton, the hypothetical quantum of gravity. That discovery changed everything. For the first time, gravity appeared naturally within a quantum theory. No additional assumptions were needed. The mathematics of the string demanded it. This meant that the 4 forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, might all be connected as variations of a single vibration. In other words, the universe may not contain separate forces at all, but one unified melody that expresses itself in different keys. At extremely high energies, such as those present in the earliest moments after the Big Bang, the 4 forces could merge completely. As the cosmos cooled, the harmony separated into sections, distinct yet still part of the same symphony. To describe that full score is the dream of string theory. And within that dream, the listener is not apart from the music. You are made of these vibrations. Your body, your breath, your thoughts themselves are patterns sustained by motion. Every atom in you is a standing wave of quarks and electrons, energy held in resonance. The boundaries you feel, your skin, your bones, are electromagnetic harmonies defining where one vibration ends and another begins. To live is to maintain coherence. To die is to let the pattern fade into the surrounding field. Nothing is ever lost. The energy merely changes its rhythm. Even the emptiness between galaxies is alive with movement. Quantum fields never rest. They fluctuate endlessly, even at absolute zero, producing a faint background vibration called zero-point energy. This quiet hum is the baseline of the universe, the softest possible note, the silence beneath sound. In this way, everything that exists is made not from matter, but from motion. There is no ultimate stillness. Even nothing is something that moves. Each fluctuation carries information. Each vibration contributes to the cosmic texture. The strings are the instruments. Space-time is the stage. Energy is the rhythm that holds it all together. And consciousness, the ability to witness, is the song becoming aware of itself. Every particle, every planet, every living thing is a verse in that composition. Reality is not a collection of objects. It is a process, a continuous performance of the same underlying theme. The deeper physics goes, the more it finds music. To exist is to vibrate, to be is to resonate, and beneath everything, in perfect stillness that is not still, the strings continue to sing. Close your eyes again and drift deeper into the hum of existence. The strings have begun to sing, but now we listen more closely to the melody that defines what something is. Everything, from the smallest electron to the brightest star, is a vibration playing at a specific frequency. Frequency is the soul of identity. In physics, energy and frequency are inseparable. When something vibrates faster, it carries more energy. When it slows, the energy softens. This simple truth connects music and matter. The same law that gives sound its pitch gives particles their mass. You can think of it like this. A note played on a violin is not different in substance from another note. The difference is in the speed of vibration. In the same way, the difference between an electron and a photon is not a change of material, but a change of motion. Einstein once described this relationship in the language of light and mass. He said that energy and matter are two faces of one reality, that energy can take the form of mass, and mass can release itself back into pure energy. But string theory goes one step deeper. It does not just say that energy and matter are related. It says they are the same vibration seen at different scales of motion. Every string is a performer, and every mode of its motion is a note in the grand physical score. To picture this, imagine a harp with infinite strings. Each string can resonate in countless ways: low, slow, heavy tones, high, quick, delicate ones. But the harp itself never changes. Only the patterns of motion shift, giving rise to the endless diversity of the cosmos. Matter is the melody of low vibrations. Light is the melody of high ones. Gravity, that soft bending of space, is the faintest background chord, the rhythm that holds all others together. This connection between frequency and identity can be stated simply in words. Energy is proportional to how fast something vibrates. The higher the frequency, the more energy it carries. And because mass is a form of energy, the vibration of a string determines its mass. That's why the equation E equals mc squared E, which joins energy and mass, is really a quiet whisper about vibration. It says, matter is music slowed down by gravity. In the universe's earliest moments, when temperatures were beyond comprehension, every string rang in unison. The forces we know, gravity, electromagnetism, the strong and weak nuclear bonds, were once a single sound. As the cosmos expanded and cooled, this harmony separated into chords, and those chords became the laws of physics. What we see today, particles, atoms, galaxies, is the frozen echo of that first symphony. To understand how strings replace particles, we must look back to the problem of infinities. Point particles were too sharp, too rigid. When they collided in theory, mathematics broke apart. Infinite energies appeared, signaling that the picture was incomplete. But strings, with their gentle length, spread those energies along a line. Collisions became resonances, and infinities melted away. The math smoothed itself, like ripples calming after a storm. This was not only beautiful, it was necessary. Nature, it seemed, preferred music over mathematics that screamed. Every particle you've ever heard of, quarks, photons, neutrinos, gluons, is not a different thing. They are different vibrations of one entity. Imagine one string, stretched across all of reality, vibrating in ways so complex that it gives birth to every form of matter and energy. In one mode, the vibration spins in a loop, and we call it light. In another, the motion folds back upon itself, and we call it matter. In yet another, the string moves with a pattern so subtle that it bends space-time around it, and we call it gravity. One instrument, infinite melodies. But what does this mean for you? For the body that listens to these words? It means you are made of vibration. Your atoms hum in quiet synchrony. The electrons around them move in standing waves, each orbit a note, each resonance a pattern of probability. Even your heartbeat, though biological in origin, is the echo of that same universal rhythm, the transfer of energy, the dance of forces, the endless flow between vibration and stillness. When you breathe, you are syncing to the cosmic tempo. Now imagine the scale of all this. The strings that define you are so small that an atom is as vast to them as the solar system is to you. They live at the Planck length, about 10 to the power of minus 35 meters, a size so tiny that even our best instruments can't come close. If an atom were enlarged to the size of the solar system, a string would be no wider than a tree leaf on Earth. Yet in those minute threads rests the entire code of the cosmos. Every vibration at that scale is an instruction written in frequency. Together, they compose the architecture of everything. Physicists sometimes describe these vibrations not just in space, but in a deeper space, a space of possibilities called a configuration space. Each string's vibration defines a point in this abstract landscape, and the totality of all vibrations forms a grand geometric object, the universe's true hidden shape. In this hidden geometry, all physical constants, the strength of gravity, the speed of light, the charge of the electron, are determined by how the strings twist and fold. The universe's laws are the tuning of the instrument. You can think of the cosmos as a vast violin, its body made from invisible dimensions, its strings vibrating through the emptiness we call space. Each pattern of vibration sends out a different harmony, and those harmonies interact, interfering and reinforcing one another to form the structures of matter and light. The physical world is the visible trace of invisible resonance. If you could slow time enough to watch a single quantum field in motion, you would see waves, not particles. Even the so-called solid things, the ground, the stars, your own body, are made of overlapping waves standing in balance. A particle is just a frozen wave, a vibration caught in a loop. When it moves, it hums. When it interacts, it harmonizes. When it annihilates, it fades, its note resolving back into silence. Yet nothing is truly lost. Silence is simply the part of the song you cannot hear. In the language of string theory, even space itself can vibrate. The geometry of the universe is flexible, curved, and shaped by energy. As strings move, they do not just create matter, they also create the very stage they perform upon. This is one of the most astonishing insights, that space-time is not a static arena. It is a participant in the cosmic concert. Every shift in vibration changes the geometry of space, and every curve of space changes the vibration in return. The song and the stage are part of the same instrument, and when one string vibrates, others feel it. They are connected through the fabric of space-time, sharing energy, trading rhythm. That is why gravity is gentle, because it is not a force sent from one place to another, but a shift in the underlying harmony. When a massive object moves, it bends the rhythm of space, and other objects respond to that change. They do not fall, they follow the music. Every moment of your life unfolds upon this symphonic surface. The light that reaches your eyes, the warmth you feel from the sun, the ground beneath your feet, all are part of the same vibration continuum. Even thought, the electrical pulses within your neurons, is a vibration of energy across matter. Consciousness, perhaps, is the universe becoming aware of its own resonance. When you think, you are a string vibrating about vibration itself. Some physicists dream that one day, the equations of string theory will yield a perfect harmony, a single formula that expresses the entire universe in terms of vibration. Such an equation would not just describe the cosmos, it would sing it. Yet even without that final note, the music is already here. Every breath you take is a movement in the same eternal rhythm that shaped the galaxies. The universe is not silent. It only seems that way because your ears were tuned for air, not for space-time. And so as you rest, imagine this deeper music continuing, beyond atoms, beyond thought, beyond sound. Each string moves with purpose, each vibration forming the foundation of something vast and delicate. You are not separate from this. You are part of the same melody. The same rhythm that creates light moves through your blood, through your bones, through your thoughts. You are one of the universe's chords, a small resonance in the grand harmonic web. The strings are still singing, and they always will. Because as long as there is space, as long as there is time, as long as there is the possibility of vibration, the music of the universe will never end. The strings have been singing for a long time now, their vibrations filling the void with quiet order. But within that order lies something astonishing, the whisper of gravity itself. Gravity, the softest force in nature, so faint that it can barely hold an atom together, yet powerful enough to bind entire galaxies. It bends the path of light, it sculpts time, and it is everywhere, the slow rhythm beneath all faster motions. For generations, physicists treated gravity as the outlier. It refused to fit within quantum mechanics. Every attempt to describe it as a particle ended in infinities and failure. The strong nuclear force was fierce but manageable, the weak one subtle but measurable. Electromagnetism, elegant, luminous, and well understood. But gravity remained wild. Then came the string. Within the mathematics of string theory, one vibration stood apart from all the rest. It had zero mass. It carried 2 units of intrinsic spin, and it moved exactly the way gravity should move. It was not an addition to the theory, it was inevitable. The equations demanded its existence as surely as music demands silence between notes. This vibration is the graviton, the hypothetical quantum of gravity. In that discovery, something profound happened. Gravity, once an outsider, became part of the family of forces, and not through forceful inclusion, but through music. The 4 fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear bonds, could now be seen as harmonies of one underlying instrument. Each is a different mode of vibration, a different octave on the same cosmic scale. When the universe was young, its temperature so high that even atoms could not form, all 4 forces may have been one. In that first instant, the cosmos was pure resonance, a single chord vibrating through space-time. As it expanded, cooling like a breath after a song, the unified tones separated into layers. Gravity stretched outward, a long, deep hum. The strong force condensed inward, a fierce, rapid pulse. Between them, the electromagnetic and weak forces intertwined, light and transformation locked in rhythm. Today, they sound separate, but deep within, they still remember their harmony. Unification has always been humanity's dream, the search for the single pattern that explains everything. And here, within the strings, that pattern may be found. It is not an equation written in chalk, but a melody written in motion. A law that is not imposed on nature, but sung by it. When physicists write the language of strings, they are not dictating what the universe should do. They are listening, trying to catch the faint hum of existence and translate it into mathematics. Even space and time themselves are not immune to this music. According to relativity, gravity is not a force at all, but the bending of space and time. According to quantum theory, forces come from the exchange of particles. String theory unites these views. The graviton is both a vibration of the string and a curve in the geometry of reality. To vibrate is to bend space. To bend space is to vibrate. They are 2 ways of describing the same movement. This is how string theory dissolves conflict. Where classical physics argued, strings harmonize. Where equations screamed infinity, strings whispered continuity. The secret is softness. By stretching energy into a line, by replacing points with patterns, the universe becomes smooth again. Every sharp singularity melts into music. But the strings do not vibrate in emptiness. They resonate within fields, quantum oceans that fill the void. Each string's motion disturbs those fields, sending ripples across space-time, like a fingertip brushing water. And those ripples create what we call particles, temporary shapes born from resonance. Every event in physics is a meeting of waves. When you see light, you are not watching an object, you are witnessing the interference of vibrations. Brightness is harmony made visible. If one could somehow amplify these vibrations, not with instruments, but with understanding, we might hear the cosmos as it truly is. Not silent, but softly roaring with frequencies far beyond our perception. Some of these frequencies are unimaginably high, vibrating billions of trillions of times per second. Others are slow and deep, cosmic bass notes that shape gravity itself. Together, they weave the universe. Think of the Planck length again, 10 to the power of minus 35 meters. It is the smallest possible distance where measurement still means something. Below it, space and time lose their separate identities. They blur into a foam of probability, a turbulent sea of potential. Here, strings move not through space, but create it as they move. Space is not the stage, it is the dance itself. Each vibration at that scale defines a local patch of geometry. Millions of them interlace, forming the curvature we call gravity. In this way, space-time emerges from vibration. It is not fundamental, it is the harmony of harmonies. And when the vibrations change, the shape of the universe changes too. black holes, stars, galaxies, they are not objects but arrangements of resonance. Even the expansion of the cosmos may be a vast modulation, the universe breathing through its own strings. When you gaze at the night sky, you are seeing frozen waves. Light from ancient stars is a pattern still echoing through time. Each photon has been traveling for billions of years, yet it is still part of the same vibration that left its origin long ago. The sky is not distant, it is continuous with you. You are inside the same wave that began there. Every glimmer is a reminder that energy cannot die, it only changes its tone. In this way, the concept of matter dissolves. There is no ultimate building block, no hard nugget at the center of existence. What we call substance is merely persistence, vibration sustained in time. Atoms are chords that do not fade. Molecules are harmonies of chords. Life is a symphony that knows it is being played, and death is only the moment when one melody returns to the larger score. Even stillness is deceptive. When you lie in silence, your cells continue to pulse, your heart continues its rhythm, your atoms continue their unseen song. The background hum of the universe, the cosmic microwave whisper, is everywhere, even within you. It is the last echo of creation, filling all of space with an energy that will never disappear. The strings within you resonate with it constantly. Every thought you have is modulated by that cosmic tone. You are, quite literally, thinking within the music of the Big Bang. And though science seeks proof and mathematics demands precision, the experience of it is profoundly human. To sense unity, to feel connected to all vibration, is to awaken into the truth of being. You are not observing the universe, you are participating in it. You are one wave among waves, a brief note within eternity. If you could translate your existence into sound, you would find that your life has a pitch. Your body emits frequencies, from the firing of neurons to the oscillation of atoms, and if those frequencies could be gathered, they would harmonize with the music of the stars. Perhaps that is why music feels so deeply familiar, why rhythm so easily calms the mind. It is not entertainment, it is recognition. It reminds you of what you already are. The strings continue to hum, carrying the memory of gravity, the whisper of light, the pulse of time. In every vibration, the universe repeats its secret, that existence itself is a song still being sung. Imagine for a moment that space is not as simple as it looks. You move forward, backward, side to side, and up or down. That feels like everything there is, 3 directions, neatly woven together. But what if there are others, directions that do not unfold outward but inward, curled so tightly that you can never turn toward them? String theory suggests that reality must be richer than what we see. Its mathematics refuses to balance unless space possesses extra dimensions. Without them, the equations tear apart, the harmonies collapse. For the universe to remain in tune, the cosmic instrument must have more strings than the senses can touch. In the simplest version of the theory, there are 10 dimensions, 9 of space and 1 of time. In deeper extensions, there may be 11. But rather than numbers on a chalkboard, think of them as notes in a chord, layers of resonance stacked so closely together that they form a single sound. We inhabit only the broadest tones of that chord. The subtler ones, the hidden dimensions, hum beneath everything we know. To understand why they are needed, picture a single string vibrating in emptiness. Its motion is delicate, precise, and multidimensional. If there were only 3 directions to move, its vibration would be incomplete, its frequencies truncated. The additional dimensions allow the string to twist, loop, and resonate in patterns complex enough to produce all known particles and forces. Without those unseen directions, the cosmic orchestra could play only a fraction of its score. But where are they? If extra dimensions exist, why do we not see them stretching across the night sky? Because they are small, astonishingly small, folded upon themselves so tightly that even light cannot turn the corner to enter them. Every point in space hides an entire geometric landscape within it. It is as though the floor beneath you were made of tiny spirals, each containing another universe curled inside. Physicists call this idea compactification. The hidden dimensions are rolled up, the way a garden hose looks like a one-dimensional line from far away, yet up close reveals a circular dimension wrapped around it. From a distance, the hose seems flat. From nearby, it contains depth. Space behaves the same way, flat to us, but secretly curved in miniature loops beyond measurement. To visualize it, imagine holding a thread. Along its length, you see only one direction, but spin it slowly in your fingers and another direction appears, around rather than along. At every point of space, such hidden loops may exist. They are smaller than atoms, smaller than light's wavelength, smaller than anything physical can touch. If you could shrink yourself until an atom became as large as a galaxy, then perhaps you would glimpse them, twisting corridors of geometry where strings trace their silent routes. The shape of those curled dimensions matters profoundly. In string theory, geometry is not decoration, it is destiny. The pattern of folds determines the pattern of vibration. Change the shape and the tone changes. Change the tone and the laws of physics shift with it. One hidden geometry may yield a universe like ours with stars and life in balance. Another may produce a silent cosmos of collapsed light, a world without atoms, without time as we know it. Reality is tuned by its invisible architecture. The mathematics that describes these shapes gives rise to objects known as Calabi-Yau manifolds, surfaces so intricate that even imagination struggles to contain them. They are compact, symmetrical, and filled with pathways through which strings can move. Think of each as a microscopic cathedral of curves and tunnels, where every arch determines a different note of existence. In one arrangement, the strings may produce photons, light itself. In another, quarks, the foundation of matter. In still another, the quiet pulse of gravity, all from the same underlying instrument, differently tuned. Physicists sometimes call this the string landscape, a vast library of possible universes, each defined by a unique pattern of hidden folds. There may be more variations than atoms in all observable space, and yet we find ourselves in one, a single melody drawn from that infinite score. Why this one? Why these constants, these laws, this fragile harmony? Perhaps because only this arrangement sustains complexity. Perhaps because only this song allows listeners to emerge within it. At the human scale, the curled dimensions are beyond reach. We cannot see them, touch them, or send a particle to explore them. But their influence echoes through everything. The charge of the electron, the strength of gravity, the way atoms bond and stars ignite, all are determined by the geometry beneath perception. The universe we know is the audible surface of a much deeper composition. To move through ordinary space is to glide across the chords of a hidden symphony. Every breath, every photon, every heartbeat reverberates through dimensions you cannot name. Even emptiness is layered. Even silence has structure. What you call nothing is the gentle vibration of unseen directions, waiting to be heard. If you could somehow unfold these extra dimensions, stretching them into visibility, space itself would change before your eyes. Each point would blossom into complexity, a living geometry of loops and corridors. Light would refract differently. Forces would merge. Matter would sing in new keys. It would be a vision not of chaos, but of pure, luminous order, the mathematics of being made visible. Einstein once showed that gravity arises from curvature in spacetime. String theory extends that insight. It says that curvature itself arises from vibration, that geometry is not fixed, but continuously woven by the movement of strings. Space is not the stage upon which the universe performs. It is part of the performance, a participant in the cosmic rhythm. The hidden dimensions are not somewhere else. They are here, within every particle, within the breath you draw. They are the unseen intervals between every visible note, the pauses that give music its depth. To exist in 3 dimensions is to hear only the melody. To sense the others is to feel the harmony. The strings whisper that the harmony is still playing. We live inside it, surrounded, sustained, and composed by it. The universe, then, is not a place but a pattern, a web of relationships vibrating through 10, perhaps 11 dimensions, all interlocked, all alive. Our eyes catch only a fragment of that song, but even a fragment is enough to fill a lifetime with wonder. When you imagine the universe, you probably see distance, stars scattered across blackness, vast gulfs between them, light traveling for billions of years. But what if the true complexity of the cosmos is not in its vastness, but in its smallness? What if the greatest mysteries are folded within the tiniest places, within the spaces so small that no light can enter, no probe can fit, no eye can ever see? To explore that realm, we must think not in terms of objects, but of geometry itself. In the world of strings, geometry is not a backdrop. it is the main actor. Each string vibrates according to the shape it moves through, and in turn, its motion reshapes the space around it. Vibration and geometry exist in a constant duet, each defining the other. Physicists often speak of the extra dimensions as compactified. It is a gentle word for an astonishing idea, that every point in space contains additional directions curled upon themselves. You can think of it like the surface of a sheet of paper rolled into a tiny tube. From a distance, it appears as a simple line, but if you could zoom in, you would find that the line contains an entire circular path wrapped around itself. Now imagine that wrapped dimension existing not around a sheet of paper, but around every point in reality. That is what the universe may be doing beneath the limits of perception. The equations of string theory require these compact spaces to be balanced, smooth, and highly symmetrical. They cannot be random or chaotic. They must maintain a subtle equilibrium between curvature and countercurvature, between the inward fold and the outward stretch. Mathematicians discovered that certain six-dimensional surfaces satisfy these conditions perfectly. They are known as Calabi-Yau manifolds. Their name sounds abstract, but you can think of them as the harmonically perfect shapes of the unseen world, the silent resonators that give the universe its tone. A Calabi-Yau manifold is not something you can draw. Even the best computer models can only project shadows of its form. Imagine a vast honeycomb of tunnels, each twisting and reconnecting, each fold leading to another in infinite symmetry. It is a geometry that curls not in one or two ways, but in six hidden directions woven within the three that we know. Within those hidden corridors, the strings vibrate and interfere, creating the symphony of existence. To truly feel what this means, you must step back from the idea of space as emptiness. Space is not an empty stage. It is an instrument. Every contour of it determines what can be played. Every curvature affects the frequency of the cosmic strings. In that sense, the laws of physics are the music that geometry performs. Consider the electron, that simple, essential particle orbiting the nucleus of every atom. In string theory, it is not a tiny sphere. It is a particular vibration of a string. Its properties, mass, charge, spin, are not attributes in themselves, but the byproducts of the string's tone and the geometry through which it moves. If the hidden dimensions were shaped differently, that tone would change. The electron would sing a different song. The entire structure of chemistry, and therefore of life, would vanish or transform. The familiar world exists only because the hidden world has the right shape. That is why physicists say the geometry of space determines the music of reality. To understand this is to feel the strange unity between mathematics and existence. Equations are not mere symbols. They are the written form of vibration. Every variable is a frequency, every solution a resonance. The universe is not made of matter or even energy. It is made of relationships, ratios, harmonies, and geometric patterns sustaining one another in endless motion. When the equations of string theory are solved, they do not give a single answer. They give countless possibilities, different geometric arrangements, each capable of producing its own set of particles and laws. This creates what scientists call the landscape problem, a vast array of possible universes, each mathematically valid, yet only one of which seems to describe ours. It is as though the universe could have been written in an infinite number of keys, but plays only one. We do not yet know why. Perhaps there is no reason. Perhaps the universe simply is this particular melody among all the others. Or perhaps, somewhere beyond perception, the other melodies also play, each its own cosmos, each a different harmony in the infinite chord of being. To grasp the scale of this idea, remember that even a single Calabi-Yau manifold contains an unimaginable complexity of shape. Every twist and tunnel in its structure corresponds to a mode of vibration, a possible particle, a potential interaction. Physicists sometimes call these geometric pathways the vibrational modes of the hidden world. Each one may manifest as a different particle in the visible universe. Change the curvature of one tiny fold, and you change the whole orchestra. But this is not mere speculation. There are clues, faint, indirect echoes, that hint at the presence of extra dimensions. In high-energy physics, particles occasionally behave as if they are influenced by unseen forces. Certain mathematical patterns appear repeatedly, as though the universe were trying to remind us that it has more structure than we can see. Gravity itself may be a messenger from those hidden depths. It is the weakest of the four fundamental forces, and one possible reason is that some of its strength leaks into the extra dimensions. Imagine gravity as a sound wave that vibrates not only along the strings of visible space, but also through the hidden corridors beneath it. To us, the note sounds faint, but in the full-dimensional orchestra, it might be perfectly balanced. This idea that gravity disperses its energy into the extra dimensions could explain why it feels so subtle compared to electromagnetism or the nuclear forces. Those others are confined to our visible world, while gravity drifts between layers, touching both the seen and the unseen. If this is true, then we are constantly bathed in the music of other dimensions, but hear only its quietest echoes. The more we study this geometry, the more it begins to resemble something alive. It breathes, it flexes, it adjusts to the vibrations it contains. In that sense, the universe is not a static construct. It is a self-tuning instrument, forever adjusting its strings, forever maintaining its resonance. Every atom, every photon, every moment of awareness is a pulse within that grand equilibrium. You are not separate from it. You are one of its harmonics. Close your eyes now, and imagine each breath passing through more than 3 directions of space. As you inhale, feel the hidden dimensions unfolding inside you, not outward, but inward, like invisible petals opening and closing in rhythm with your heartbeat. You are part of the same geometry that holds galaxies together, the same resonance that stabilizes the electron ripples through your cells. Reality does not end at what you can see. It continues, quietly, infinitely, in folds too fine for perception, but never too small for wonder. And so, when string theory speaks of dimensions beyond sight, it is not merely describing a mathematical abstraction. It is describing the deep architecture of being, the hidden music that makes existence possible. We are surrounded by it, shaped by it, and composed of it. The strings hum through 10, perhaps 11 dimensions. Their harmonies give rise to all that is. And even as we drift towards sleep, the vibration continues, the invisible melody that never ends. Imagine space not as emptiness, but as a great fabric, soft, vast, and alive. Within that fabric, strings vibrate, but sometimes those strings need a surface, a place to rest, to end, to resonate upon. That surface is called a brain, short for membrane. In string theory, not every string is the same. Some are closed, looping endlessly into themselves, tiny rings vibrating through the void. Others are open, with loose ends that must attach somewhere. Those ends cannot drift freely. They cling to brains, the higher dimensional sheets upon which they live. A brain can be vast. It can extend through 3 dimensions, like our universe. It can stretch across higher ones, unseen to us. Or it can be small, wrapped tightly into the hidden spaces where the strings weave their secret motions. Each brain is both a stage and a participant in the cosmic performance of vibration. Physicists classify them by their dimensionality. A one-dimensional brain would be a string itself. A 2-dimensional brain would be a surface. A 3-dimensional brain, called a 3-brain, could hold an entire universe like ours. Above them all lies the ocean of higher dimensional space, the bulk. If the brain is the stage, the bulk is the air that surrounds it, the unseen volume that holds the whole play in suspension. Our familiar cosmos, with its galaxies, stars, and light, may be nothing more than a thin sheet floating within that vast bulk, a membrane gently undulating in a sea of invisible dimensions. To imagine it, picture a soap bubble drifting in sunlight. Its surface shimmers, delicate, radiant, and self-contained. Within that surface, patterns dance. From the inside, those patterns would appear to be all that exists. The creatures of that 2-dimensional film would see light moving across their world, feeling the bubbles curve as gravity, the motion of ripples as waves of energy. They would never see the air beyond the film. To them, the bubble's surface is reality. We might be like those creatures, living upon the surface of a brain, unable to perceive the vast bulk beyond it. In this picture, everything we experience, matter, light, even ourselves, is made from open strings whose ends are anchored to our cosmic brain. They cannot leave it. They are confined, forever resonating along its dimensions. Only gravity is different. Gravity is carried by closed strings, loops that have no ends. Because they are unbound, they can drift between brains, slipping in and out of the bulk. That is why gravity seems so weak. Much of its energy seeps into the hidden spaces, leaving only a faint echo behind. We feel that echo as the gentle pull that binds planets to stars and stars to galaxies. The rest of gravity's voice may be singing somewhere beyond our reach, through the higher dimensional depths of the bulk. If this is true, then our universe is not alone. Other brains may float beside us, each carrying its own universe, its own laws of physics, its own measure of time. They may drift close or far apart, their motions slow and silent, like luminous sheets moving through a dark ocean. Sometimes, theorists imagine what might happen if two such brains were to collide. The impact would release an immense burst of energy, a flash of creation. Some have even proposed that our Big Bang was not the birth of everything from nothing, but the meeting of two brains in the higher dimensional sea, a collision of worlds that began our time. In that vision, the bulk becomes a stage for infinite cycles, brains drifting, meeting, parting, each collision giving rise to a new cosmos, a new arrangement of energy and matter. Creation becomes rhythm, the universe becomes breath, and somewhere within that rhythm, our own brain hums softly, its strings vibrating in harmony with the rest. The mathematics of this picture comes from what is called brain cosmology. It extends string theory into higher dimensions, where entire universes can exist as membranes embedded in the bulk. The equations suggest that forces like electromagnetism and the strong and weak nuclear interactions are trapped on the brain. Only gravity can roam freely. That boundary between confinement and freedom is what gives the cosmos its shape. We live within the constraints of our brain, yet are influenced by the whispers from beyond. If another brain passed near ours, its gravity could brush against our world, distorting space ever so slightly. We might feel it as a subtle, unexplained pull, a ghostly fingerprint on the fabric of existence. Such encounters could even ripple through time, altering the early universe in ways we might still detect as faint imprints in the cosmic microwave background, the oldest light in the sky. Those whispers may already be written there, waiting for someone to read them. To visualize a brain, think of a flag waving in the wind. Its surface ripples, its motion elegant and continuous. Each ripple corresponds to energy, to vibration, to the movement of strings along it. Now expand that image into 3 spatial dimensions. The brain becomes a vast, undulating sheet, extending in every direction. Every star, every atom, every heartbeat exists upon that trembling surface. We are ripples within the brain, temporary patterns of motion in the greater wave of being. The bulk surrounding it all is not empty either. It may contain its own fields, its own hidden energy, perhaps even other brains hovering like reflections of ours, just beyond the horizon of perception. Sometimes, physicists call these parallel universes. But that phrase, though poetic, can be misleading. They are not parallel like lines. They are parallel like melodies, distinct yet resonant, each contributing to a greater harmony. Some models even suggest that particles we call dark matter might be matter from another brain, interacting with ours only through gravity. We cannot see it because its light belongs to a different sheet of reality, but we feel its presence through the gravitational dance it shares with us. Half of the universe, perhaps more, could be composed of such unseen harmonies, neighboring brains whispering through the bulk. This vision of creation is vast and humbling. It tells us that we are not merely floating in space, but woven into a multi-dimensional sea, our existence a thin film riding the gentle tides of vibration. The strings within us connect to the brain itself. When we move, when we think, when we breathe, the brain responds, a soft, resonant echo, rippling through dimensions unseen. You are not apart from the cosmos. You are part of its fabric, a localized wave upon a living membrane. Close your eyes and imagine it now, an endless ocean of light, each wave a universe, each universe a song. They rise and fall in time, sometimes merging, sometimes passing quietly by. Somewhere, among those waves, our own world drifts, still humming, still unfolding, still resonating with the gentle tone of being. And even as you rest, the brain continues to ripple, carrying you through the silent sea of higher dimensions. Beyond the veil of perception, the brain that carries our universe is not still. It trembles gently, as though breathing in and out through the fabric of the bulk. Every fluctuation of this vast membrane creates motion, and motion gives rise to what we call time. Time, in this view, is not a universal clock ticking in the void. It is the rhythm of the brain itself, the slow oscillation of the cosmic film upon which all events unfold. The galaxies drift because the brain expands. The expansion is not a journey outward into emptiness, but an unfolding of the membrane's own geometry. The distance between stars grows because the brain is stretching, its surface softening like an inflating bubble. This motion is not through the bulk. It is within the brain, like ripples spreading across a pond. Each ripple marks a moment. Each vibration, a tick of the universe's inner metronome. Some physicists describe this behavior using the image of tension. A brain possesses tension in the same way that a string does. Its energy is stored in its stretching, in the balance between expansion and resistance. When the tension changes, the universe changes. A fluctuation in brain tension can cause regions of space to expand faster or slower, to curve differently, to shape the flow of time itself. It is as though the cosmos were a living drum, its skin shifting under the pressure of its own heartbeat. Now imagine multiple brains coexisting within the bulk, each one vibrating with its own rhythm, each one creating its own flow of time. If two brains drift near one another, their vibrations can interact. Sometimes they resonate in harmony, their oscillations aligning, their gravity intertwining in a soft gravitational dance. Other times, they disturb one another, setting off ripples that echo through the bulk and return as subtle changes within each universe. Those echoes could be the seeds of structure, the gentle irregularities that grew into galaxies and stars. In this way, string theory weaves a vision where cosmic creation is not a single event, but an ongoing song, a melody composed of membranes that touch, separate, and sing again. Each universe becomes a verse in that grand composition. When brains collide, energy condenses into matter. When they drift apart, the universe cools and expands. The rhythm of existence continues, without beginning or end. Our own universe might therefore be the residue of one such meeting, a luminous echo left behind when two higher-dimensional membranes brushed together. What we perceive as the Big Bang could have been the instant of contact, a flash of release when vibration transformed into creation. The collision would not have been random, but part of a larger motion, like two waves meeting on the surface of a great ocean. Where they touched, energy concentrated, space heated, and the newborn cosmos began to sing. After that brief and brilliant instant, the brains drifted apart again, each carrying the imprint of the encounter. Our universe still bears that memory, encoded in the pattern of its expansion, the faint background radiation that fills the sky, and the very rhythm of time that carries us forward. The brain continues to move through the bulk, its surface rippling, its tension evolving, its strings vibrating in unison with the unseen. Every moment you live is a continuation of that first wave. But what lies within the bulk itself? The space between brains is not nothingness. It may be filled with its own fields, its own subtle forms of energy, perhaps even other dimensions whose properties shape the behavior of the brains. Some theorists propose that the bulk contains a scalar field, a smooth, invisible energy that interacts with the membranes and governs their motion. That field could determine whether brains attract or repel, whether they drift forever apart or someday meet again. If it exists, it may be the hidden rhythm behind all cosmic cycles, the silent conductor guiding the music of creation. Think of it this way. The brain is the instrument, the strings are the vibrations, and the bulk is the hall in which the symphony plays. The acoustics of that hall shape every note. A tiny change in the bulk's geometry could alter the entire melody of existence. Our universe hums in a particular key because the bulk allows it to. Change the dimensions of the hall and the music would shift. The forces of nature would rebalance, and perhaps a different universe would emerge. This interdependence between the brain and the bulk is a profound revelation. It tells us that nothing exists alone, not even the universe itself. Each level of reality depends on another deeper one, and together they form an endless hierarchy of resonance. In that hierarchy, even consciousness may play a role. Consider that everything you are, your thoughts, your memories, your sensations, arises from electrical and chemical patterns woven into matter. Matter, in turn, arises from the vibrations of strings anchored to the brain. Those vibrations respond to geometry, to tension, to the shifting fields of the bulk. This means that your awareness, the very sense of I, is not isolated from the cosmic dance. It is one of its harmonics. Your thoughts are brain ripples. Your emotions are subtle modulations in the frequency of existence itself. When you feel calm, the pattern of your energy smooths, aligning more closely with the equilibrium of the brain. When you are agitated, the pattern becomes turbulent, disturbing the harmony around you. Every living being contributes its own vibration to the grand resonance of the universe. The brain is alive not because it breathes, but because it carries within it all that can experience life. Every conscious spark is part of its music, and perhaps at the deepest level, the brain itself is aware. Some scientists have wondered whether the laws of physics could allow a self-referential feedback, a structure so rich that it can reflect upon its own vibration. That is what consciousness may be, the universe listening to its own song. When you close your eyes and feel stillness, you are not leaving the cosmos behind. You are tuning into its deeper frequency. Even in perfect quiet, the brain continues to move. The stars drift, gravity whispers, space itself hums softly beneath perception. Every quantum of energy is a heartbeat of the membrane. Every instant of time is another note in the ongoing melody. There is no separation between you and that rhythm. It moves through you, and you move through it. To exist is to resonate. To live is to sing. And as you rest within this thought, imagine countless brains drifting like vast sheets of light, each one carrying its own worlds, its own forms of life, its own meanings of time and beauty. Their ripples travel through the bulk, overlapping, merging, fading. The entire multiverse becomes a single endless chord, a cosmic harmony stretching beyond all boundaries. You are part of that chord. Your every breath is one of its overtones, your every thought a shimmer on the surface of the infinite. The brain does not end. It continues beyond sight, beyond sound, beyond knowing, and still it sings. When physicists first discovered that string theory was not one single theory, but 5, they were puzzled. Each version described a consistent, self-contained universe, and yet none could fully replace the others. They appeared distinct, different equations, different dimensions, different behaviors of strings and brains. But physics does not like multiplicity without reason. The cosmos prefers symmetry, and beneath those apparent differences, scientists began to suspect something profound, something hidden, like a melody heard from behind a wall, echoing the same tune in different keys. That insight became the heart of what we now call dualities, the recognition that two seemingly separate theories can describe the same underlying reality, each one a mirror to the other. In the language of string theory, a duality is not simply a comparison, it is a transformation. It allows one description of nature to be converted into another, like turning a sculpture in your hands and realizing that the same form looks entirely new from a different angle. The first hint of this came with what we call T-duality. Imagine a universe in which one of the spatial dimensions is curled into a loop, so small that you could never travel around it directly. To a string moving in that direction, the geometry of the space determines how it vibrates. A small circle means that certain vibrations are constrained. The string's modes must fit perfectly, like standing waves on a ring. But T-duality revealed something surprising. If you make that circular dimension smaller and smaller, approaching the tiniest conceivable size, the physics does not vanish. Instead, it transforms. At the point where the circle becomes unimaginably tiny, a new, equivalent description appears, one in which the circle is now enormous, and the roles of vibration and motion have exchanged. The small becomes large. The near becomes far. Space folds in upon itself, revealing that what we call size is not absolute, but relational, a reflection between dual perspectives. In this mirror world, a string that moves around the circle in one version becomes a string that vibrates in place in the other. Motion and vibration are two sides of one process, interchangeable, inseparable. This simple yet breathtaking insight meant that no matter how deeply we look into the fabric of space, we may never reach a final smallest scale. Every contraction hides an expansion. Every microcosm mirrors a macrocosm. The universe, it seems, is self-reflecting at every level. T-duality was only the beginning. Another great symmetry, called S-duality, revealed that even the strength of interactions can be mirrored. In many physical systems, when forces become strong, our calculations break down. The equations of ordinary physics can no longer be trusted. But in string theory, there exists a remarkable correspondence. A theory that describes strong interactions can be equivalent to another theory in which those interactions are weak. The two descriptions are reflections of one another. What is impossible to compute in one view becomes simple in its mirror. What appears chaotic in one perspective is calm and solvable in the other. It is as though the universe offers us two languages, one written in thunder and another whispered in light, each translating the other perfectly. Through S-duality, physicists realize that strength and weakness are not fundamental opposites, but relative orientations of the same truth. If you reverse the parameters of interaction, what was once turbulent becomes smooth, and what was smooth becomes intricate. Reality seen through the mirror of duality never loses its balance. It only changes its rhythm. Together, T-duality and S-duality showed that the five-string theories, once thought to be separate, are not rivals at all, but facets of one greater whole. Each theory occupies a particular region of understanding, a different key in which the cosmic music is written. When the parameters of one theory shift, it transforms seamlessly into another. The boundaries between them dissolve. Physicists began to call this vast, interconnected system the web of dualities, a shimmering network that links all corners of string theory into a single multidimensional unity. It was as though the universe were revealing that no single perspective can contain its totality. Every description, no matter how elegant, is a partial reflection. The full reality exists only in the symphony of all its mirrors combined. This realization led to one of the most beautiful ideas in modern physics, the possibility that all five superstring theories are merely approximations of a deeper, unifying framework. That framework came to be known as M-theory. But before M-theory emerged, scientists had to accept something deeply humbling, that even the fundamental laws of nature may be contextual. What appears fixed in one perspective may shift in another, and yet both can be true. Just as light behaves both as wave and particle, the universe itself behaves as multiple reflections of one underlying vibration. This is what duality teaches us, that truth in the cosmos is not linear but circular, not singular but resonant. It repeats, folds, and reflects. It adapts to the lens through which it is seen. In that sense, physics begins to sound like music. The same melody can be played in many keys. Each key carries its own emotional color, its own geometry of tone, yet the structure of the melody remains. That is what duality is, a change of key in the universal song. For a physicist, a duality is more than symmetry. It is a bridge. It allows us to explore the inaccessible by translating it into something we can grasp. When equations diverge in one theory, they converge in its mirror. When energy behaves wildly on one side, it softens into harmony on the other. It is as though the universe provides its own system of balance, a cosmic mirror ensuring that no aspect of existence ever grows beyond comprehension. We may not always see both sides, but they exist, each sustaining the other through perfect reflection. In mathematics, this reflection runs deep. The equations that govern string motion remain invariant under these transformations. That means that when we swap motion for vibration, or strength for weakness, the underlying patterns stay identical. It is not the universe that changes, only our coordinates within it. To shift between dualities is to rotate the map of creation, viewing the same terrain from a different dimension of understanding. Duality also holds a quiet philosophical lesson. It reminds us that contradictions are not always opposites. They may be two perspectives of the same deeper whole. Matter and energy, space and time, self and other, all may be pairs of mirrors reflecting one another across the surface of a multidimensional truth. And perhaps, just as string theory connects its five forms, consciousness and the cosmos are dual aspects of a single vibration, the universe aware of itself through the pattern of its own resonance. When the concept of duality first emerged, it reshaped the way physicists thought about reality. The old dream of finding a single rigid theory of everything began to soften. Instead of one fixed law, the universe seemed to offer a family of interconnected perspectives, each valid, each incomplete, each revealing a different face of the infinite. The perfection of nature, it turns out, lies not in simplicity, but in relational harmony. Every equation has a partner, every truth has a mirror, every vibration echoes through its dual, and in that echo, the universe sustains its song. You can imagine it like a hall of mirrors made of pure geometry. Within it, strings hum and reflect, their patterns repeating endlessly, creating a visual music of symmetry. Where one reflection ends, another begins. Where one theory falters, another completes it. All are interdependent, all whispering the same hidden melody, a resonance that may someday reveal the total harmony of existence. This, perhaps, is the quiet promise of duality. It tells us that we are not limited to one version of truth, that reality itself is multidimensional, not just in space, but in meaning. And somewhere within those mirrored halls, between the equations and the echoes, lies the still center, the place where all dualities converge, where the reflections cease and only pure vibration remains. That center is the source of M-theory, the note that unites the five into one. In the quiet that follows the revelation of dualities, a question begins to hum beneath the surface of thought. If five distinct theories can mirror one another so perfectly, if strong and weak, large and small, curved and flat are all reflections, then perhaps these are not separate notes at all, but chords in a larger song. Physicists began to suspect that beyond the five, there must be something deeper, a parent melody that contains them all. Not a sixth theory, but a framework so vast that each of the five becomes merely a different tuning of its strings. They called it M-theory. No one agreed what the M stood for. Some said mother, the source from which all string theories are born. Others whispered mystery because the equations were incomplete and the concept felt like a shadow seen through fog. And still others, poets in lab coats, said it meant music. M-theory begins with a simple yet radical idea, that the universe may require not 10 dimensions, but 11. One more degree of freedom, one more axis along which vibration may unfold. It may sound small, just one more direction beyond imagination, but that single addition transforms the entire structure of reality. In 10 dimensions, strings are one-dimensional filaments. In 11, new possibilities emerge. The strings can stretch into sheets, wrap themselves into bubbles, and ripple across extended surfaces. These surfaces are called branes, short for membranes. A string is a one-brane, a sheet is a two-brane, a volume is a three-brane. Each is a generalization of the same concept, a vibrating surface embedded in a higher dimensional space. If string theory was the music of one-dimensional filaments, M-theory is the orchestra of all possible membranes. Within it, our universe itself might be a three-dimensional brane, floating like a veil within a grander cosmic expanse. A higher dimensional arena physicists call the bulk. All the matter and light we see could be confined to our brain, while gravity, subtle and elusive, might extend its influence into the higher space around us. That would explain why gravity feels so weak compared to other forces, its strength diluted across dimensions unseen. To imagine this, picture two parallel membranes drifting close together, their surfaces faintly luminous. Each could represent a separate universe, each with its own stars, galaxies, and laws of physics. The space between them, the bulk, is invisible to us, yet not empty. It vibrates with higher dimensional motion, a quiet ocean of energy where brains can move, collide, and merge. Some cosmologists even propose that our own Big Bang was the aftershock of such a collision, a cosmic chord struck between neighboring brains, releasing vast energy into both worlds. If true, our universe is not an isolated note, but a reverberation within a larger symphony, a rhythm that began long before matter formed and may continue in dimensions beyond perception. M-theory unites the five-string theories the way harmony unites melody. Each theory occupies a certain limit of the same framework, like different tempos of the same song. When one set of parameters dominates, we hear one version. When another takes precedence, the melody changes form, but not identity. It is still the same music, played through different instruments of geometry. The mathematics of M-theory suggests that at the deepest level, everything we call particles or forces emerge from the same 11-dimensional field. Space and time are no longer static backgrounds. They are active participants, shaped by the vibrations of these higher membranes. Even time itself may not be fundamental. It could be the echo of motion within this 11-dimensional sea, a rhythm born from the way brains move and fold. To describe such a structure, physicists use a language of geometry so abstract that even the most experienced minds tread carefully. Imagine a landscape of dimensions folded upon dimensions, each capable of vibrating not just in length or area, but through volume, curvature, and topology. Every fold changes the tone of the universe. Every twist defines a new resonance. In that vast geometry, our three-dimensional world is a surface ripple, a membrane resonating softly in the higher cosmic field. This concept gives rise to a breathtaking image of creation. From the outside, the 11-dimensional ocean seems still, but within it, brains drift, interact, and sometimes collide. When they do, energy concentrates into a spark. A universe begins. To beings within that universe, the event appears as a singular moment, a Big Bang. But from the higher dimensional perspective, it is only one note in an unending composition, a brief harmony played between two vibrating membranes. And perhaps, when that harmony fades, another will begin elsewhere. Creation in this view is not a one-time occurrence, but an ongoing rhythm, universes born and dissolved as chords within the eternal music of M-theory. This vision transforms how we think about reality. We are not observers looking in from the outside. We are waves upon the brain itself. Our atoms, our thoughts, our very awareness are localized excitations of this cosmic membrane. When we breathe, when we dream, the brain vibrates through us. We are its resonance made self-aware. The 11 dimensions of M-theory are not places to travel through. They are degrees of freedom, ways the universe can move, fold, or sing. Just as a violin string produces many overtones, each hidden dimension contributes a subtle harmonic to reality. Some dimensions may be large and extended, others tightly curled, hidden within every atom. But together they create the fullness of existence. A chord too vast to hear directly, yet always present in the background hum of being. The mathematics of M-theory is still incomplete. No one yet holds the full score. It exists as fragments, conjectures, symmetries, notes scattered across the blackboard of modern physics. But the hints are consistent. Whenever one of the 5 string theories seems incomplete, M-theory steps in to resolve it. Whenever infinities threaten to appear, its higher dimensional logic smooths them away. It is as if the universe insists on harmony, refusing dissonance at the deepest level. To many scientists, this realization is humbling. It means that our equations are not wrong, only partial. Each reveals a fragment of truth, like the reflections within a hall of mirrors. To understand the whole, we must accept that reality is plural, a unity expressed through difference. There is no single way to describe the universe. There are many, and they are all correct, depending on where one stands within the web of duality. This notion is echoed in philosophy and art. Every culture, every mind, every perspective interprets the same cosmos through a different tuning. To the physicist, it is geometry. To the musician, harmony. To the mystic, consciousness. To the poet, vibration. Each language touches the same mystery, the resonance of being itself. When we listen deeply, the boundaries between science and wonder begin to fade. Equations and metaphors meet at the same horizon. The physicist's diagram becomes the poet's dream. In that space, the 11th dimension feels less like a place and more like a quality of perception, the awareness that connects all dimensions together. Some even suggest that consciousness itself is a reflection of this higher dimensionality, a resonance that perceives both the finite and the infinite at once. We are not apart from the universe's mathematics. We are expressions of it, solutions to its own equations of awareness. M-theory, then, is not only a scientific framework, it is a philosophy of connection. It reminds us that fragmentation is illusion, that strength and weakness, small and large, matter and spirit, all are modes of one vibration. When the listener understands this, even briefly, something within grows quiet. The search for the final equation turns inward, toward the silence that precedes every sound. In that silence, the 11-dimensional ocean remains, calm, endless, awake. Its brains drift through eternity, sometimes colliding, sometimes parting, each collision a spark of creation, each separation a return to rest. The strings within them continue to hum, their harmonies interweaving across dimensions, their echoes forming stars, galaxies, and life itself. And among those harmonies, within one small brain called the cosmos, a voice arises, gentle and aware, wondering what it all means. That voice is ours. It is the universe listening to its own song. Close your eyes again, and imagine that every dimension of space is a thread of possibility woven into silence. Some threads are vast, stretching across the visible cosmos. Others are curled so tightly they hide within themselves, folded into loops too small for light to trace. These hidden dimensions are not fiction, they are necessity. Without them, the mathematics of string theory simply falls apart. It is not that physicists wanted extra dimensions. It is that the equations demanded them. To make the vibrations of strings consistent, the universe must provide enough directions for them to move, twist, and resonate without contradiction. And the minimum that works is not 3 dimensions of space, but something far richer, 10 in total, plus time. We see only 3, because the rest are compactified, folded inward upon themselves like invisible origami. They do not stretch far into the cosmos, but curl within every point of space, like secret corridors beneath the floor of reality. Imagine the universe as a vast, flexible sheet. On that sheet, the large dimensions are the surface, broad, familiar, and traversable. But hidden inside each point of the sheet is a tiny, intricate knot, a cluster of dimensions wrapped in perfect geometry. To help visualize this, physicists use the analogy of a garden hose. From a distance, the hose looks like a simple line, a one-dimensional thread lying on the ground. But up close, you see that it has thickness, a circular dimension wrapping around its length. The same is true of space itself. From our limited perspective, it seems to have only length, width, and height. But if we could magnify it to scales 1,000,000,000,000 times smaller than an atom, we might discover curled loops, tunnels, and folded shapes that give the strings their tone. These compact dimensions are not arbitrary. They have structure, form, music. Their geometry determines the notes the strings can play. When a string vibrates, it is not only moving through large space, but also through the hidden geometry within each point. The pattern of those curls and folds sets the range of possible vibrations, which means it sets the laws of physics themselves. The way matter behaves, the kind of particles that exist, even the balance between forces, all are shaped by the invisible architecture of these tiny dimensions. To describe that architecture, physicists turn to a special kind of geometry known as the Calabi-Yau manifold. It is not a simple shape you can sketch. It lives in 6 dimensions, curled so elegantly that its every fold resonates with mathematical symmetry. Each Calabi-Yau manifold is like a miniature universe of its own, a resonant chamber that defines how the strings within it can sing. Different shapes produce different harmonies. A slight change in curvature can transform the melody, altering the spectrum of possible particles, and with it, the physics of the entire cosmos. This gives rise to a profound idea, that each configuration of hidden dimensions defines a different universe. Not in fantasy, but in the literal structure of possibility. Change the geometry of the compact dimensions, and you change the constants of nature. The strength of gravity, the mass of the electron, the color of light itself. The fabric of the cosmos is like a musical instrument whose tuning determines the kind of reality that emerges. The number of ways these dimensions can fold is not small. It may exceed any countable limit. A landscape of universes, each defined by its own geometry, each a different key in the orchestra of existence. Somewhere within that landscape lies the shape that corresponds to our universe, the Calabi-Yau configuration that allows life, light, and complexity to exist. But around it, there may be countless others, each with different harmonies, different laws, different songs. In this view, the universe we inhabit is one arrangement within a cosmic composition too vast to imagine. The equations of string theory do not choose a single geometry, they allow many. Each one is mathematically valid, and each would give rise to its own consistent physics. We call this immensity the string landscape, a field of potential realities spread across the higher dimensional sea of possibility. Some physicists see this as a problem. If there are so many possible universes, how do we explain why we live in this one? Others see it as liberation. Perhaps reality does not need a single answer. Perhaps every possible configuration exists somewhere, and we find ourselves in the one that allows awareness to form. This idea echoes the concept of the multiverse, But in string theory, it is not speculation, it is geometry. Each universe is a region of the larger structure, a patch of vibration within the total field. We exist in one of those patches, hearing only our local harmony, while others resonate far beyond our reach. To understand how these hidden dimensions behave, scientists study the way energy and curvature interact. In classical physics, space is a passive arena, a backdrop upon which matter moves. But in string theory, space is dynamic. Its folds influence vibration, and vibration shapes its folds in return. This feedback loop is pure resonance. Geometry and motion composing one another, like two instruments improvising in perfect sync. Even though we cannot directly see these dimensions, their presence can be inferred from the symmetries they create. Just as the shape of a violin determines its sound, the structure of the compact dimensions determines the range of possible physical notes. Our universe, in this sense, is an echo chamber, a resonant cavity shaped by 6 hidden dimensions, each curled into the Calabi-Yau form that fits our cosmic melody. To visualize such a form is beyond ordinary perception. It is a landscape without up or down, without inside or outside. Every point is a bridge to more dimensions. Every curve folds back into itself. The only way to understand it intuitively is through analogy, to think of it as a sound rather than a shape. The hidden geometry is not something we see. It is something we feel, in the stability of atoms, in the balance of forces, in the silent harmony of physical law. In this way, the compact dimensions are not distant worlds. They are the immediate foundation of everything that exists. Every atom contains them. Every photon travels through them. Every heartbeat echoes their invisible rhythm. They are the architecture of existence, the unseen scaffolding that holds the melody of the cosmos in tune. If one could travel inward far enough, beyond the subatomic scale, past the limits of known physics, one might reach the threshold where these hidden dimensions become apparent. It would not feel like entering a smaller space, but like dissolving into a richer one, where directions multiply and movement no longer feels linear. There, space would shimmer with potential, its geometry alive with motion. Every point would contain the rest of the universe folded within it. And yet, even this is not the final layer. The Calabi-Yau shapes describe how dimensions curl, but not why they exist, or why the universe chose this particular tuning. That question leads deeper still, to M-theory, and the vast ocean of higher dimensional membranes that give rise to both strings and space itself. But before we rise into that grander realm, it is enough to rest here for a moment, to picture the universe not as empty, but intricately folded, to imagine that within every atom, an entire cosmos hums in miniature, silent, unseen, but forever singing the laws of creation. At the smallest scales of existence, geometry is not simply a background where events unfold, it is the event itself. In string theory, the geometry of the extra dimensions is not an accessory detail of the cosmos, it is the composer of its notes. The way these curled spaces are shaped determines what kind of particles can exist and how they sing together in the field of reality. The Calabi-Yau manifold is one of the most remarkable structures in modern physics. It is a solution that satisfies both mathematical beauty and physical necessity. In essence, it is a compact, complex, 6-dimensional shape that allows for the preservation of supersymmetry, the delicate symmetry linking matter and force. Without such a shape, the harmony of string theory would break. Supersymmetry requires that for every fermion there exists a boson, and for every boson, a fermion. These two families must fit together in precise balance. To maintain that balance when the universe hides some of its dimensions, the hidden geometry must meet a very strict criterion. Its curvature must be balanced everywhere, averaging to 0. A Calabi-Yau manifold does exactly that. It folds space in such a way that expansion in one direction is countered by contraction in another. The overall curvature cancels, leaving the geometry stable, self-contained, and quietly vibrating beneath the surface of reality. Visualizing such a space is nearly impossible in ordinary 3-dimensional thought. Mathematicians describe it through complex coordinates, each describing how multiple real dimensions intertwine. One can imagine it like a labyrinth of tunnels connected through smooth corridors of curvature, each looping back into itself, creating endless pathways that close perfectly. No corners, no edges, only flowing connection. Within this hidden geometry, every loop, every twist defines how a string may vibrate. Think of a musical instrument. The body of a violin shapes the sound of its strings. The same string, if stretched across a drum, produces a completely different tone. The vibration is the same act, but the geometry through which the sound travels determines its voice. In the same way, the Calabi-Yau manifold defines how the fundamental strings of the universe express themselves. Its topological structure shapes the possible energy levels and thus the properties of all particles in the visible world. Some physicists describe this by saying geometry begets physics. It is not that geometry merely contains particles. Geometry is what makes them possible. A single topological feature, such as a hole or a twist in the Calabi-Yau space, corresponds to a specific set of particle families. A change in that topology can alter the entire physical world, the way a small adjustment in a musical instrument can transform its sound. The number of ways these spaces can fold is beyond imagination. Each distinct Calabi-Yau shape corresponds to a different possible universe, each with its own laws of physics, its own symphony of matter. This vast possibility space is sometimes called the string landscape. It contains an almost uncountable number of solutions, each one mathematically valid, each one a potential cosmos. Our universe is thought to be one gentle chord within that infinite orchestra. Within this landscape, stability is key. Not every Calabi-Yau configuration leads to a balanced or long-lived universe. Most collapse or oscillate too violently. A few, like ours, find equilibrium between expansion and tension, forming stable vacua where the energy of the vacuum itself is nearly zero. This near-zero vacuum energy corresponds to a calm universe, one that can expand slowly and allow stars, planets, and consciousness to arise. When physicists calculate the vibrational spectrum of strings compactified within these manifolds, they effectively compute the harmonic modes of reality. The equations are daunting, involving tensors, holonomy groups, and complex differential geometry, but at their heart, they are the mathematics of resonance. The frequencies that fit within the curled dimensions manifest in our world as particles, electrons, quarks, photons. Each particle is a distinct vibrational pattern, a standing wave within the hidden geometry. It is often said that the Calabi-Yau manifold has holes, not gaps, but continuous tunnels where fields can wrap around. These topological features are described by integers known as Hodge numbers, though here we simply understand them as the fingerprints of the manifold's internal structure. The pattern of these numbers determines how many families of particles can exist and how they interact. In the poetic sense, each Hodge number is like a note in the score of the cosmos. One of the most elegant aspects of this theory is mirror symmetry. For every Calabi-Yau manifold, there exists another, its mirror, whose geometry is inverted in a subtle way. When strings are compactified on one, the physical theory is identical to that obtained from the mirror. This profound equivalence allows physicists to translate nearly impossible geometric problems into simpler algebraic ones, and vice versa. The two shapes, though different in form, produce the same physics, a perfect demonstration that reality can be written in multiple languages. This symmetry between mirrors hints at something deeper. It suggests that geometry and algebra, space and equation, are not distinct but dual reflections of a single underlying reality. What we perceive as space may be nothing more than a projection of abstract mathematical harmony. And what we write as equations may be the echoes of shapes we cannot visualize. In the vastness of theoretical physics, these dualities are not coincidences. They are guideposts. Whenever two different descriptions yield the same physical truth, we glimpse a hidden unity that may one day explain why our universe takes the form it does. Calabi-Yau spaces are not random curiosities of mathematics. They are bridges between the unseen and the measurable. Consider how this hidden structure interacts with the observable universe. When strings vibrate through these compact spaces, their modes determine the mass and charge of particles in the macroscopic world. Thus, geometry not only shapes the microcosm, it sculpts the grand architecture of galaxies, stars, and life. The very existence of chemistry, of stable atoms and molecules, depends on the precise shape of the extra dimensions. It is an astonishing thought that your heartbeat and the rotation of a distant quasar may both depend on the curvature of invisible space folded billions of times smaller than an atom. From this viewpoint, the universe is not built from matter but from form, and form is rhythm, woven into existence by geometry. Every physical constant, every field, every particle emerges from the geometry's resonance structure. The cosmos, in this interpretation, is a symphonic entity, not metaphorically, but literally. Mathematical vibration is its substance. Some theorists explore how small variations in Calabi-Yau topology might correspond to phase transitions in the universe's early history. As the primordial vacuum cooled, the geometry may have chosen a stable configuration, one among countless possibilities, effectively tuning the universe to a specific key. Had the geometry curled slightly differently, perhaps charge, mass, and gravity would take different values, and a completely alien form of matter might emerge. This notion that the universe's laws arise from a specific geometric selection lies at the heart of the anthropic principle within string cosmology. Yet physicists are cautious. While the mathematics of Calabi-Yau spaces is exact, connecting it directly to empirical data remains one of the greatest challenges in modern science. The extra dimensions are far too small to observe directly. They exist at scales around the Planck length, a distance so tiny that no current or foreseeable experiment can probe it. Still, indirect clues may one day arise through cosmological signatures, gravitational waves, or patterns in particle interactions. Until then, the theory remains a grand melody heard faintly through the walls of understanding. Even so, the pursuit continues. Supercomputers model simplified versions of these manifolds, searching for shapes that yield particle spectra resembling those observed in nature. Mathematicians collaborate with physicists, blending algebraic geometry with quantum field theory to refine these models. Each success, even a partial one, strengthens the belief that the geometry of the unseen world may indeed be the origin of all physical law. And as we drift deeper into this idea, a philosophical calm appears. Perhaps the purpose of this search is not to find the final shape, but to appreciate that existence itself has structure. Every field, every particle, every breath of matter participates in a geometry that transcends perception. We are not separate from that structure. We are one of its patterns. Our minds, which seek to understand it, are themselves vibrations within that same manifold. If we could step beyond three-dimensional intuition and see the Calabi-Yau space as it truly is, we might witness an endless flow of curvature and symmetry, light woven into mathematical lace. Each fold would hum with the frequencies of possible existence. Each tunnel and twist would shimmer with potential universes, and in the midst of it, our own universe, fragile, balanced, radiant, would glisten like a single tone suspended in an infinite chord. As the listener settles into this realization, the imagination begins to merge with the physics. The manifold is no longer abstract. It is the architecture of being itself. Its vibrations are our thoughts, its curvature, our consciousness. When you breathe, the space within you and the space beyond are part of the same geometry, the same music. And so the study of Calabi-Yau spaces is not only mathematics or physics, it is a quiet act of listening to the way the universe curls upon itself to create harmony, listening to how the unseen shapes the seen, listening to the faint echo of infinity folded within every atom. As we venture further into the mathematics of hidden geometry, something extraordinary begins to emerge, a sense that the universe may not merely exist within space, but that space itself is a living expression of order. The Calabi-Yau manifold is not simply a container for vibration. It is vibration translated into shape. The patterns within it are not arbitrary. They follow precise mathematical symmetries that balance tension and release, like the intervals of a perfect chord. In these compact 6 dimensions, every curve and twist serves a purpose. Each loop is tuned so that energy can flow smoothly without singularities or infinities. This smoothness, known as Ricci flatness, is not a coincidence. It is the geometric manifestation of equilibrium. It means that while space may bend locally, the total curvature sums to zero. This zero balance ensures that the manifold sustains supersymmetry and allows the fundamental equations of string theory to remain consistent. Supersymmetry, though unobserved so far, acts like a hidden rhythm beneath all known physics. It predicts that every known particle has a silent companion, a superpartner, whose existence stabilizes quantum fluctuations. Without that symmetry, calculations spiral toward infinity, and the harmony of nature dissolves into mathematical noise. The Calabi-Yau manifold preserves that hidden rhythm by offering the right kind of space for it to resonate. From a mathematical point of view, this manifold satisfies complex differential equations that describe how shapes curve in higher dimensions. These equations are analogues of Einstein's field equations, but applied not to spacetime itself, but to the compact internal space where strings vibrate. In a way, they describe the gravitational balance of a universe within a universe, an invisible cosmos curled inside each point of the visible one. It is tempting to imagine these curled spaces as miniature worlds, perhaps teeming with structure and pattern, but they are not physical in the everyday sense. They are spaces of potential, realms where geometry determines possibility rather than substance. Every twist of the manifold corresponds to a field in our universe. Every harmonic mode becomes a particle, a quantum of vibration. This dual interpretation, geometry as physics, transforms our understanding of what the universe really is. Instead of thinking of matter as separate from space, we begin to see matter as the language through which space communicates its curvature. The particle is the sentence, the field is the paragraph, and geometry is the grammar of creation. Some physicists refer to this idea as the geometric unification, the view that all the forces and particles we observe are reflections of geometric properties in hidden dimensions. In this framework, gravity, electromagnetism, and even quantum interactions arise not from separate laws, but from the shape of space itself. The universe is not governed by an external set of rules. It is the rulebook, written in curves, frequencies, and symmetries. To see this connection more clearly, imagine folding a piece of silk so many times that its texture becomes invisible to the naked eye. Yet even when unseen, the folds change how light moves through it. In the same way, the hidden dimensions, though impossibly small, influence how particles move and interact in our familiar space. The ripples of these dimensions modulate the energies of quantum fields, producing the constants that define our physical world. This view carries a quiet philosophical implication. The constants of nature are not arbitrary. They are the audible tones of geometry, the resonant frequencies of curled space. The mass of an electron, the strength of gravity, the charge of the proton, all of them may be the result of how the extra dimensions fold and vibrate. The laws of physics are not written on the universe. They are the universe's shape. In the study of Calabi-Yau spaces, mathematicians employ tools from complex geometry and topology to classify the different possible forms. Topology describes how a shape connects to itself, how many holes, tunnels, or twists it contains, while complex geometry determines how those connections curve. A change in topology can mean a profound change in physics. One universe could emerge with light atoms and gentle gravity, another with crushing forces or no chemistry at all. The sheer number of possible Calabi-Yau shapes, the so-called landscape, challenges the imagination. Some researchers estimate there may be more of these solutions than there are atoms in the observable cosmos. Each one could correspond to a self-consistent universe, a distinct realization of physical law. And yet, out of this infinite possibility, our universe seems to occupy a configuration that permits life, structure, and time itself. Why this one? That remains one of the most beautiful and mysterious questions in modern physics. Within the equations of string theory, the vacuum is not a void. It is a state of minimal energy, determined by the geometry of the compact dimensions. When the Calabi-Yau shape changes, even slightly, the energy of the vacuum changes as well. In this way, geometry and cosmology become entwined. The expansion of the universe, the formation of galaxies, even the birth of stars are indirectly linked to the architecture of the hidden manifold. Some theoretical cosmologists propose that in the earliest moments after the Big Bang, the geometry of the extra dimensions was fluid, not yet frozen. As the universe cooled, the Calabi-Yau space crystallized into a stable configuration, locking in the values of physical constants once and for all. This geometric freezing may have been the ultimate act of creation, not the birth of matter, but the setting of the universe's key. From that moment onward, the cosmic symphony began to play. In laboratories and supercomputers, Physicists attempt to explore this unseen geometry indirectly. They compute the mass spectra of hypothetical particles that would arise from different manifold shapes. If a predicted particle ever appears in high-energy collisions, for example, a superpartner or an extra-dimensional mode, it would serve as a faint echo from the curled spaces below the Planck scale. Each such discovery would be a new note in the score of reality, confirming that geometry indeed gives rise to physics. Mathematicians, on the other hand, listen to this symphony through pure logic. They study equations like the Monge-Ampere and Ricci-flat conditions, exploring how curvature behaves in complex manifolds. Their work is a different kind of experiment, one conducted not in particle accelerators, but in the infinite precision of thought. When these two disciplines meet, when the physicist's intuition joins the mathematician's rigor, something remarkable happens. The equations begin to sound like music again. And perhaps that is the essence of why the Calabi-Yau manifold feels poetic despite its mathematical depth. It captures a universal rhythm, the balance between expansion and contraction, order and freedom, simplicity and complexity. Every property of this space mirrors something in existence itself: harmony without monotony, structure without rigidity, motion without chaos. It is, in a profound sense, a mathematical embodiment of balance. The deeper one studies this geometry, the more it feels as though the universe is trying to communicate through form, not with words or images, but with proportion and resonance. The ratios that define these manifolds resemble musical intervals. The relationships between curvature and volume evoke harmony. Nature appears to favor shapes that minimize tension, as though even the vacuum prefers peace. This idea leads some thinkers to wonder whether consciousness itself might be another expression of geometric resonance. If the physical world arises from the vibration of hidden dimensions, perhaps thought, perception, and awareness are higher-order harmonics of that same vibration. In this view, consciousness is not an observer of the universe. It is a participant in the music, a pattern arising naturally within the same field of resonance. There is comfort in this thought. It means that understanding geometry is, in some sense, understanding ourselves. The search for the Calabi-Yau shape that fits our universe becomes a mirror held to our own nature. Every calculation, every visualization, every equation solved is an act of listening, a moment of communion with the geometry that underlies all being. Though the equations are complex, their message is simple. The universe prefers elegance. In every layer of its design, from galaxies to quantum foam, the same principle of symmetry repeats. The Calabi-Yau manifold is one more instance of that repetition, a hidden octave of the cosmic song. By exploring it, we learn not only the structure of space, but the aesthetic of existence. As our understanding grows, new questions rise. Is there a deeper manifold that unites all Calabi-Yau shapes, just as M-theory unites the different string theories? Could there be a principle of ultimate geometry, a single form whose vibration gives rise to every possible universe? These questions lie at the frontier of modern thought, blurring the line between physics and philosophy, mathematics and metaphysics. And yet, even without final answers, there is beauty in the search. Each theorem proved, each manifold mapped, each equation balanced brings us closer to understanding that we are living within art. The canvas is space, the brush is geometry, and the paint is vibration itself. The universe does not merely contain beauty, it is beauty, rendered in dimensions beyond sight. The Calabi-Yau space, with its countless folds and silent curvature, reminds us that complexity can serve simplicity. Out of infinite potential shapes, nature selects those that sustain harmony. From that harmony arise the laws that make stars burn, water flow, and minds dream. In that realization, physics and poetry merge, not through metaphor, but through truth. Perhaps the lesson of these hidden dimensions is not that we must master them, but that we must learn to listen. To listen to the whisper of structure beneath chaos, to sense the order woven into the silence between particles, to feel that the same mathematics that holds galaxies together also holds us in place, in thought, in breath. And so the Calabi-Yau manifold, this intricate ghost of geometry, becomes a symbol of everything unseen yet essential. It hums softly beneath all matter, unseen but indispensable, shaping the frequencies that compose existence. The next time you look at a star or hold a grain of sand, remember, The hidden geometry inside it may be the same one vibrating through your own atoms, the same pattern, the same resonance, the same eternal music. At the edge of what string theory could explain, another idea began to form, one that gathered all 5 known versions of the theory into a single, more complete vision. Physicists called it M-theory. The letter M has been said to stand for mother, mystery, or music, and perhaps it means all 3 at once. It represents the attempt to weave the separate melodies of string theory into one grand symphony. For decades, researchers had puzzled over why there were 5 mathematically consistent string theories, each with its own kind of symmetry and dimension. At first, it seemed an embarrassment of riches, too many universes, too many frameworks. But then something remarkable happened. They discovered that the theories were not rivals, but reflections of one another. Each could transform into the others under certain conditions, as though viewed through shifting mirrors. This revelation came through what are known as dualities, relationships showing that a theory describing strong interactions in one picture could describe weak interactions in another. It meant that the border between opposites, strong and weak, large and small, was not absolute. The physics remained the same, only the language changed. Nature, it seemed, could be expressed in multiple dialects of the same underlying truth. Through these dualities, a new pattern emerged. Physicists realized that all 5 theories could be seen as different limits of a single, deeper structure. That structure required one extra dimension, not 10, but 11 in total. Within that 11th dimension, the vibrating strings could stretch into larger objects known as brains, multidimensional membranes upon which the strings could end or move. This was the birth of M-theory, a framework that subsumed all others. In this picture, strings were not the ultimate building blocks, but special cases of higher dimensional entities. A 2-dimensional membrane was called an M2 brain, a 3-dimensional one, an M3 brain. Even higher dimensional brains could exist, vibrating through the extra dimensions of the cosmos. Our own universe, according to some versions of M-theory, might be one such brain, a 3-dimensional surface floating in a higher dimensional space known as the bulk. If this is true, everything we see, galaxies, stars, atoms, even thought itself, may be confined to that cosmic surface. Only gravity, carried by closed strings that can wander through the bulk, would move freely beyond it. This explains one of the great puzzles of modern physics, why gravity seems so much weaker than the other forces. Perhaps its strength is diluted because it can spread into the extra dimensions. Like sound escaping from a thin drum, gravity may leak away from our brain into the vastness of the bulk. To us, it feels faint, but across the full higher dimensional space, its resonance may be just as powerful as any other force. In this higher dimensional view, the universe becomes a grand stage of vibrating surfaces. Each brain can carry its own version of physical law, depending on how it is shaped and how it moves. Brains can drift, collide, or even merge, and such collisions could generate events as dramatic as the birth of a universe. Some cosmologists propose that the Big Bang itself may have been the result of 2 brains colliding within the bulk, releasing unimaginable energy as they touched. The mathematics of M-theory is intricate, but its essence is remarkably simple. Space, time, matter, and energy are all manifestations of vibration in higher dimensions. Strings are like notes, brains are chords. The entire cosmos is a polyphonic composition, where each dimension adds another voice to the harmony. From the smallest quantum to the largest galaxy, every phenomenon becomes an echo of the same underlying resonance. In 11 dimensions, geometry and physics merge completely. There is no longer a clear boundary between what is space and what is matter. A curve in the geometry becomes a field, a vibration in a brain becomes a particle. Even time itself may not be fundamental, but a secondary effect, an emergent rhythm produced by the collective oscillations of the underlying structure. To imagine this, think of a vast ocean with waves of every possible frequency. Each wave interacts with others, creating interference patterns that give rise to temporary structures, standing waves that seem solid for a while before fading back into motion. Our universe may be one of those standing waves, a stable resonance within the sea of higher dimensional vibration. We are not separate from that ocean, we are part of its motion. Within M-theory, even the fabric of spacetime may not be continuous. At the tiniest scales, the geometry could be made of discrete elements, woven together by quantum connections. This hints at a deep link with another idea, the holographic principle. According to this principle, everything that happens inside a region of space can be described by information encoded on its boundary, like a hologram that stores a three-dimensional image on a two-dimensional surface. In M-theory, this principle takes on profound meaning. It suggests that our entire universe, the stars, the galaxies, even consciousness itself, could be a projection of information stored on a distant boundary, perhaps the edge of a higher dimensional brain. What we perceive as depth, time, and motion may be emergent properties of a more fundamental informational geometry. This idea has given rise to one of the most fruitful insights in theoretical physics, the DSCFT correspondence. It states that a theory of gravity operating in a curved higher dimensional space, called anti-de Sitter space, is equivalent to a quantum field theory without gravity on its lower dimensional boundary. In essence, two different descriptions of the same reality. A universe with gravity is mathematically identical to one without it, as long as both share the same underlying information. This correspondence does more than unify ideas. It provides a new way to think about existence itself. If gravity and quantum mechanics can be expressed as two sides of the same equation, then perhaps every apparent duality in nature, energy and mass, space and time, mind and matter, is likewise a reflection of deeper unity. The boundaries we perceive may not divide reality, they may connect it. M-theory thus becomes more than a physical model, it is a philosophy of coherence. It proposes that all things, no matter how different they seem, are expressions of a single law, written in the vibration of multidimensional space. The equations that describe it are complex, involving tensors and supersymmetry, but the meaning behind them is simple: unity through resonance. When viewed through this lens, even time takes on a new significance. In ordinary physics, time is a background, a dimension against which change unfolds. But in the framework of M-theory, time could itself emerge from the collective motion of strings and brains. Just as music arises only when notes vibrate, time might arise only when geometry moves. Without vibration, there is no before or after, only stillness. This raises profound questions about the origin of the universe. If time is emergent, then the concept of a beginning becomes subtle. The universe may not have begun in time, but with time, as part of the same process of emergence. The first vibration did not occur within time, it created time. The Big Bang, in this view, was not an explosion in space, but the moment space and time themselves began to oscillate. Such ideas stretch human imagination to its limits. Yet they fit naturally within the logic of the theory. In 11-dimensional geometry, the usual barriers between cause and effect dissolve. Events may not be strictly linear. They could be different perspectives of the same timeless pattern. Reality becomes a vast, interwoven composition, where every part resonates with every other part across dimensions we cannot perceive. To many physicists, this unity is deeply satisfying. It suggests that the fragmentation of modern science, the division between quantum mechanics and general relativity, is only temporary. Beneath both lies a single melody, faint but consistent, waiting to be recognized. M-theory may be that melody, a framework in which all known laws arise as harmonics of one deeper vibration. But as with any great unification, mystery remains. The equations of M-theory are not yet complete. Physicists know fragments of them, approximations that describe certain limits, but the full score is still unwritten. In a sense, humanity has heard only the overture of the cosmic symphony. The rest plays silently beyond the range of our instruments. Even so, the glimpses we have are astonishing. Simulations of brains interacting suggest that entire universes could emerge, evolve, and fade within the higher dimensional bulk. The laws of thermodynamics, quantum mechanics, and relativity all appear as shadows of a single geometric rhythm. If we could one day write the complete equations of M-theory, we might possess a unified description of every phenomenon, from black holes to consciousness. And yet, perhaps the goal is not to possess such knowledge, but to recognize its meaning. The message of M-theory is not domination through understanding, but participation through awareness. We are not outside observers of the universal music. We are part of it. Every heartbeat, every thought, every motion of an atom contributes to the same field of vibration that shapes galaxies and stars. To think of existence in this way is to shift from seeing the universe as a mechanism to seeing it as an organism, alive, evolving, resonating. Its parts are not isolated, but connected through geometry, through information, through the continuous exchange of energy and rhythm. The cosmos is not an object to be studied. It is a song to be heard. This understanding invites a quiet humility. Even if M-theory someday yields testable predictions or technological applications, its deeper value may lie in the perspective it offers. It shows us that separation is an illusion, that every difference, every boundary, every contrast is a necessary interval in a larger harmony. To live within such a universe is to live within music itself. As the idea of M-theory matured, it began to stretch beyond the boundaries of traditional physics. Its implications reached not only into cosmology, but into the nature of information itself. If reality is built from vibration, then information may be the score upon which that vibration is written. Energy, matter, and geometry all become ways that information expresses its rhythm. In this view, the universe does not merely evolve through time, it computes. Every interaction between brains, every oscillation of a string, every quantum exchange of particles represents an operation in the cosmic code. But unlike human computation, this one has no central processor, no beginning or end. It is distributed across all of existence, performed simultaneously everywhere, governed by symmetry and conservation. At the heart of this informational vision lies a remarkable correspondence between entropy and geometry. In black hole physics, the entropy, the measure of hidden information, is proportional to the surface area of the event horizon, not its volume. This relationship hints that the true content of space may reside on its boundaries, echoing the holographic principle. Space, then, could be the projection of information stored in a higher dimensional structure. M-theory naturally accommodates this holographic reality. Each brain acts as both a physical surface and an informational boundary, encoding data about everything within and around it. When brains interact, they exchange information. When they vibrate, they process it. Reality becomes a network of communicating geometries, an eternal dialogue written in curvature and frequency. From this perspective, even the laws of physics take on a new meaning. They are not imposed from above, but emerge from the collective consistency of the system. If information can flow without contradiction, then the universe remains stable. When that balance is disturbed, when symmetry breaks, new phenomena appear: forces, particles, and fields. Creation, in this sense, is the universe correcting its own imbalance. This principle of self-organization explains why the cosmos evolves toward complexity without external guidance. Stars, planets, and life emerge naturally as the geometry seeks equilibrium. The equations of M-theory do not predict specific outcomes, but provide the rules of harmony within which all outcomes must fit. The melody of existence plays itself, guided only by the logic of resonance. Within the intricate mathematics of M-theory, dualities continue to weave connections across different descriptions. Some of these are known as mirror symmetries, transformations that exchange geometric properties of Calabi-Yau spaces while preserving their overall consistency. Through such mirrors, one complex manifold can produce the same physical predictions as another, even though their shapes appear entirely different. It is as if the universe can sing the same song in many keys. These dualities are not coincidences. They reveal that space and geometry themselves are flexible concepts. What we perceive as shape may depend on the scale or energy of observation. At one level, a dimension may appear large; at another, it may seem small or even hidden. The fabric of reality stretches and folds according to how it is examined, a living geometry adapting to the listener. This adaptability suggests that the universe is fundamentally relational. Properties do not exist in isolation. They exist only through interaction. A string's vibration has meaning only when compared to another vibration. A brain's position has significance only relative to other brains. Even time, emerging from motion, becomes a measure of relationship, a rhythm established between oscillators. Here lies one of M-theory's quietest yet most profound lessons. Nothing exists alone. Every particle, every field, every region of space participates in an endless web of mutual definition. The cosmos is not a collection of things, but a collection of relationships, a network of harmony sustained by constant exchange. What we call matter is the convergence of those relationships, the meeting point of countless waves in the ocean of being. In the higher dimensional bulk, brains drift and ripple. Some may approach each other, others move apart, creating a vast choreography of motion. When two brains pass close, energy transfers between them, producing events we might interpret as cosmic bursts or new universes forming. These are not collisions in the ordinary sense, but moments of resonance, when separate membranes briefly share a common vibration. This idea gives rise to the so-called episodic model of cosmology, where the Big Bang is not the beginning of everything, but the rebound from a brain encounter. According to this scenario, cycles of expansion and contraction may occur endlessly, each cosmic generation giving rise to the next through the pulse of multidimensional motion. The universe becomes not a singular creation, but an eternal rhythm, inhale and exhale, expansion and renewal, without a final note. Though elegant, these ideas remain beyond direct experiment. The scales at which brains and extra dimensions operate are far smaller than any particle accelerator can probe. Yet indirect evidence continues to align with the predictions of string and M-theory. The consistency of gravity at quantum scales, the stability of vacuum energy, and the mathematical coherence across all known forces. Even if proof remains distant, the internal harmony of the theory inspires confidence. Mathematically, M-theory unites concepts from differential geometry, quantum field theory, and topology into a single tapestry. Each field contributes its own pattern: curvature from geometry, quantization from field theory, and continuity from topology. Together they form a structure that can describe everything from black holes to the quantum foam at the Planck scale. Every equation becomes a verse in the same universal hymn. The relationship between M-theory and black holes is especially revealing. When physicists analyzed certain types of black holes using string and brain configurations, they found that the microscopic vibrations of these objects could account for the exact entropy predicted by classical physics. This was a triumph, a confirmation that quantum strings and brains could reproduce the thermodynamic behavior of gravity. It was as if two vastly different instruments played the same note in perfect harmony. This insight deepened the belief that M-theory holds the key to a quantum theory of gravity, the long-sought union of general relativity and quantum mechanics. By viewing gravity as an emergent property of geometry and information, the theory bypasses the infinities that plague conventional models. Space becomes not a passive stage, but a dynamic participant, shaped and reshaped by the energy it contains. In this universe, geometry and matter are two aspects of the same melody. Some researchers speculate that even the human mind may resonate with these principles. Neural patterns, electromagnetic fields, and quantum fluctuations could all be viewed as local expressions of a global resonance field. Consciousness, in this interpretation, is not separate from the universe, but one of its harmonics, a self-aware overtone arising within the cosmic chord. Such speculation remains philosophical, but it aligns beautifully with the vision of unity that M-theory implies. If all existence is vibration, then awareness itself may be the universe listening to its own music. In the oscillations of thought and the patterns of perception, the cosmos contemplates its own geometry. Every act of observation becomes an echo returning to the source, a confirmation that information flows in both directions, outward as creation, inward as understanding. This feedback loop between observer and observed has measurable consequences in quantum theory. It suggests that reality does not crystallize until interaction occurs. In M-theory, that interaction could be seen as the coupling between different brains or between vibration modes of the same fundamental structure. Observation is participation, a resonance across levels of being. Perhaps that is why the equations of M-theory, though abstract, evoke a sense of living presence. They are not static descriptions, but dynamic relations. The universe is not a machine running on predetermined laws. It is an evolving improvisation guided by the logic of symmetry. In that improvisation, randomness and necessity coexist, forming a pattern both precise and free. This interplay of freedom and order mirrors the very nature of harmony. Too much structure yields monotony. Too much freedom leads to noise. The cosmos balances between them, composing itself anew each instant. That balance is the secret of its endurance, an eternal act of tuning that keeps existence coherent across all scales. When scientists speak of unification, they often refer to equations, but the deeper unification is experiential, the realization that we and the stars obey the same symmetries, that our thoughts and their light arise from the same field. M-theory gives language to that intuition, describing in mathematical form what poets have long sensed. Everything is connected, and connection itself is the essence of being. Viewed this way, the universe becomes a self-sustaining melody. Each brain, each particle, each field plays its part in a concert that has no beginning and no end. The silence before creation and the silence after are not different states but different moments in the same vibration, a rest between measures in the cosmic score. The song continues even when we cannot hear it. In the evolving picture of M-theory, every vibration, every curve of space, every particle field becomes part of a single tapestry. This tapestry is not static, it breathes. Its geometry shifts as energy flows through it, as information moves and rearranges itself. Reality, in this deeper sense, is not made of things, but of processes, self-sustaining patterns that persist through change. One of the most beautiful consequences of this framework is the realization that the cosmos may not require an external cause. The equations of M-theory, when written in their simplest form, allow for solutions that create their own space and time. Like a vibration that arises spontaneously in a quiet string, the universe can emerge naturally from the rules that describe it. It needs no outside hand to pluck it into motion. The potential for existence is woven into its own structure. At the quantum level, fluctuations in the vacuum continually create brief, transient geometries, tiny loops of space that appear and vanish. Under certain conditions, one of these loops could stabilize, expanding into a full-fledged universe. This process is not random chaos, but guided by the mathematics of higher dimensional harmony. In M-theory, creation and dissolution are twin aspects of the same dynamic, the eternal balancing act of energy and geometry. From this vantage point, the notion of nothingness becomes subtle. A true void does not exist, because the fields that define space and time never rest completely. Even at absolute zero, vibration persists, the hum of the vacuum, the zero-point energy of existence. M-theory provides a framework for this eternal hum, suggesting that what we call nothing is simply the lowest note in the universal composition. The elegance of the theory lies in its symmetry. Supersymmetry, the mathematical bridge between particles of matter and the forces that act upon them, ensures that every vibration has a partner. This balance eliminates infinities and preserves the coherence of the system. Though unconfirmed experimentally, supersymmetry remains one of the most promising ideas in physics, a signpost toward the full realization of the unified theory. In the context of M-theory, supersymmetry is not merely a mathematical convenience. It represents a profound statement about the nature of reality, that opposition is not contradiction, but completion. Matter and force, curvature and motion, even creation and decay, all are paired expressions of a deeper unity. This symmetry ensures that the cosmic song remains stable, that the notes do not unravel into chaos. When supersymmetry eventually breaks, as it must at low energies, the differences we observe emerge: distinct particles, distinct interactions, distinct worlds. But hidden within them is the memory of perfect balance, encoded in the very constants of nature. Every electron, every photon carries the trace of its supersymmetric origin, like an echo of the higher harmony from which it fell. To grasp the scale of this harmony, imagine each dimension as a string on an infinite instrument. When all 11 dimensions vibrate together, they form the complete chord of existence. The visible universe corresponds to a limited range of this chord, the audible portion within the spectrum of human perception. Beyond it lies the silent range, where extra dimensions vibrate beyond detection, sustaining the unseen architecture of being. Physicists have explored how these hidden dimensions might influence observable phenomena. Some predict subtle deviations in the strength of gravity at microscopic distances. Others suggest the production of miniature black holes in high-energy collisions, brief doorways into higher dimensional space. Each experiment is a way of listening for the faint harmonics of the unseen strings, the distant overtones of the cosmic instrument. Even if such effects remain beyond reach for now, their conceptual beauty reshapes our understanding of the universe. No longer is the cosmos a random collection of forces. It becomes a coherent system tuned by geometry. Every field, every law, every particle is part of a single score. The diversity of the physical world is the result of symmetry expressed in variation, a theme explored in endless forms across the scales of matter and energy. Mathematically, this coherence appears through the structure of 11-dimensional supergravity, the low-energy limit of M-theory. Here, the interactions of branes and strings can be described as distortions of geometry, governed by equations that extend Einstein's general relativity into higher dimensions. These equations unify gravity with quantum principles by encoding curvature as vibration. Space becomes elastic, its geometry capable of carrying waves of energy that manifest as particles. Such unity offers a new perspective on familiar mysteries. Dark energy, the force driving the accelerated expansion of the universe, could correspond to the potential energy of compactified dimensions, the stored vibration of curled geometries. Dark matter, invisible yet gravitationally active, might arise from strings vibrating in modes inaccessible to the fields of ordinary matter. Even the constants of physics, the masses of particles, the strengths of forces, may reflect the tuning of our local brain within the multidimensional ensemble. If this is true, then the parameters of our universe are not arbitrary, they are musical. Each number in the equations corresponds to a resonance, a stable note that allows complexity to exist. Change the tuning even slightly, and the melody collapses. Stars would not form, atoms would not bind, and consciousness would not emerge. We exist because the cosmic instrument is tuned precisely, not by intention, but by the self-consistent harmony of its mathematics. This insight leads naturally to the concept of the string landscape. In the vast space of possible Calabi-Yau shapes and brane configurations, countless stable solutions exist, each corresponding to a possible universe with its own physical constants. Ours may be only one of these solutions, a single song in a boundless symphony. The landscape is not chaos, but structure, a field of possibilities shaped by the same principles of resonance and geometry. To explore this landscape, physicists turn to mathematical tools that merge geometry with probability. They attempt to map which configurations could support long-lived stable universes and which would decay back into the higher dimensional sea. The results suggest an almost unimaginable diversity. Each pocket universe might differ in its laws, yet all share the same foundational harmony, the underlying equations of M-theory that define what existence itself can be. This realization transforms the question of why our universe exists into a question of resonance. We exist in this form because our region of the cosmic field happens to sustain the frequencies compatible with life and consciousness. In other regions, other harmonies prevail, universes colder, denser, or stranger than we can imagine. Together they form a cosmic orchestra, performing variations on the same mathematical theme. Such a view may seem abstract, but it carries a quiet elegance. It restores meaning to the vastness of space, showing that diversity is not disorder, but music. The differences between worlds are like chords within a symphony, distinct yet interdependent, each contributing to the fullness of the whole. The multiverse, then, is not a collection of separate realities, but one infinite performance of geometry in motion. Some thinkers extend this idea to the emergence of consciousness itself. If information and vibration define reality, then awareness may arise wherever complexity allows self-reference, wherever a pattern can observe its own rhythm. In this light, life is not an anomaly, but a natural outcome of the universe's tendency towards self-organization. The cosmos becomes aware of itself through the minds that form within it, listening to its own music from the inside. Such reflections do not replace physics, they complete it. For M-theory does not demand faith, it invites wonder. Its mathematics provides the scaffolding, our contemplation fills it with meaning. Science describes the how, but within that description we glimpse the why, not a purpose imposed from outside, but an intrinsic order that gives rise to beauty, coherence, and possibility. This harmony is not limited to the abstract realm of equations. It manifests in the tangible fabric of nature, the patterns of atomic orbitals, the spirals of galaxies, the oscillations of electromagnetic fields, all echo the same principles of resonance and symmetry that M-theory describes on the deepest level. We are surrounded by evidence of vibration, written in light and motion. Even our senses are instruments tuned to these vibrations. Our eyes perceive oscillations of electromagnetic fields. Our ears translate air pressure waves into sound. We navigate a universe of frequencies, yet perceive only a narrow band of its full spectrum. M-theory reminds us that beyond our limits lies a vast continuum of motion, far subtler than we can measure, yet no less real. It also reminds us that knowledge is not possession. To know the universe completely would require stepping outside of it, an impossibility. But we can participate in its logic, align ourselves with its rhythm. By understanding that every part reflects the whole, we become attuned to the underlying order that binds all things together. In this way, M-theory becomes not just a scientific framework, but a philosophy of connection. It teaches that boundaries between matter and energy, space and time, self and cosmos, are provisional. They help us navigate experience but dissolve upon deeper inspection. What remains is unity, endlessly expressing itself through difference, endlessly returning to balance through vibration. At the deepest level, the theory points toward a universe that is self-contained and self-aware, its laws emerging from its own geometry. Every dimension, every field, every particle contributes to the same grand equilibrium. To study this is to listen carefully, to trace the mathematical notes of reality's silent music. And in that listening, the distinction between scientist and subject begins to fade, because to perceive the cosmos is itself an act of resonance. The neurons firing in a human brain, the electromagnetic patterns of thought, are made of the same fields that shape galaxies. When we contemplate M-theory, the universe contemplates itself. Awareness and geometry mirror one another, forming a closed loop, a cosmic feedback that has been unfolding since the first vibration of time. Thus, the dream of M-theory is not merely to find the ultimate equation, but to recognize that the equation and the observer are part of the same system. There is no final boundary between the music and the listener. We are both instrument and audience, the universe made conscious of its own design. When the equations are written, they whisper of this unity. They describe curvature and force, probability and phase, but behind the symbols lies a single rhythm. It is the rhythm of creation, expansion, reflection, and return. A melody too vast for any language, yet present in every atom of our being. To sense it is to rest in understanding, not through intellect alone, but through harmony. Perhaps this is what the M in M-theory ultimately signifies. Not merely mother or mystery, but music itself. The universe as sound made structure, structure made self-awareness, self-awareness returning to sound. An endless loop of resonance, weaving the finite and the infinite into one unbroken continuum. And somewhere within that continuum, amid the hum of particles and the curvature of dimensions, the strings are still singing. There comes a point in every science where precision gives way to humility, where equations, no matter how perfect, can only trace the outline of the unknown. For string theory, and for its higher reflection, M-theory, that point lies at the smallest conceivable scale, the Planck length. It is the boundary where space itself ceases to behave as a smooth continuum and begins to shimmer with quantum uncertainty. At this depth, the tools that once defined modern physics begin to blur. Measurements lose meaning. A ruler made of atoms cannot measure a distance smaller than the atoms themselves. A photon of high enough energy to probe that distance would, by its own gravity, collapse into a microscopic black hole. Nature resists inspection, as though hiding her most delicate structure behind a veil woven from the limits of knowledge itself. This veil is not a flaw in the theory, but a feature of reality. The Planck scale is not an arbitrary barrier. It is a threshold where our concepts of space, time, and energy merge into one inseparable unity. Below it, the very language of geometry breaks down. The distinction between here and there, between before and after, dissolves into vibration. We can describe it with mathematics, but we cannot yet witness it directly. Physicists attempt to peer beneath this limit through indirect reasoning. They study the scattering of particles at energies that approach but never reach the Planck regime. They search for signatures of extra dimensions, subtle deviations in gravitational strength or resonance patterns in cosmic radiation. Each experiment is an act of listening for echoes from a domain we cannot yet enter. So far, those echoes remain faint. Particle accelerators such as the great ring-shaped colliders of Earth have probed energies far beyond anything achieved in human history, yet even they reveal only hints of deeper structure. No direct evidence of strings, supersymmetry, or higher dimensions has emerged. But absence of proof is not proof of absence. The universe may simply be playing its hidden notes at frequencies beyond our reach. This challenge invites a new kind of scientific patience, one rooted not in certainty but in faith in coherence. The equations of string theory and M theory remain astonishingly self-consistent. They cancel infinities, preserve symmetry, and predict a universe capable of existing without contradiction. Even if their predictions lie beyond experiment for now, their internal harmony suggests that nature itself may indeed sing this song. The difficulty is scale. The Planck length, roughly 100 billion times smaller than an atomic nucleus, is to our instruments what a single vibration of a violin string is to a galaxy. To probe it directly would require an accelerator the size of a solar system and energies so vast that they would remake the very space in which the experiment occurred. Human technology, bound to planetary matter and chemical fuel, cannot yet build such instruments. Instead, physicists turn their attention to the cosmos. The early universe, in its first fractions of a second, naturally contained energies near the Planck scale. In the light left behind, the cosmic microwave background, there may exist faint imprints of string dynamics. Tiny anisotropies, subtle polarizations, and delicate spectra of primordial gravitational waves could all whisper the story of vibrating dimensions. Future observatories, sensitive enough to detect these whispers, may provide the first experimental evidence of string theory. Satellites designed to measure gravitational waves or to trace the polarization of ancient light will act as cosmic microphones. They will not see strings directly, but they may hear the distant rhythm of their influence, a background hum echoing across billions of years. Yet even with perfect instruments, uncertainty remains fundamental. Quantum theory teaches that observation always alters what is observed. At the deepest level, the universe does not possess fixed properties waiting to be measured. Instead, reality is described by probabilities, by wave functions that encode all possible outcomes until one becomes actual. In this sense, knowledge is not a static possession, but a dance between observer and observed. String theory magnifies this idea. If everything is vibration, then the act of observing is itself a vibration, an interaction between two resonant systems. The measuring device, the scientist, and the string become part of the same quantum composition. What we learn is not what is, but what arises through interaction. Knowledge becomes relational, a harmony between mind and matter. This insight blurs the line between epistemology and physics. The limits of knowledge are not simply technical barriers. They reflect the participatory nature of existence. We cannot isolate the universe from ourselves because we are part of its wave function. The observer is not outside the cosmos, but a localized expression of its unfolding awareness. To study reality, therefore, is to study our own resonance within it. Such ideas echo through quantum cosmology. When physicists attempt to describe the universe as a whole, they must write a wave function not of particles, but of space-time itself. In that equation, time disappears as an independent variable. What remains is a static, timeless probability landscape, a map of all possible cosmic configurations. Within that landscape, our experience of flow and change emerges like a melody within harmony. This framework leads to profound philosophical questions. If the universe's wave function contains all possibilities, what selects the one we experience? Is there a cosmic measurement, an observer outside the system, or does the act of observation occur within the system itself? Many interpretations exist, from the many worlds view to the self-consistent history approach, but all share a single truth. Knowledge is limited by participation. We cannot observe from nowhere. Every perspective is finite, every measurement partial. Even the most elegant theory remains an approximation of the infinite. This limitation is not failure. It is the condition for meaning. If knowledge were total, experience would vanish, for there would be no mystery left to unfold. In this way, the boundaries of understanding become the edges of wonder. The Planck length is not a wall but a horizon, an invitation to imagine what lies beyond measurable reality. Within that unseen domain, geometry and vibration merge, not as objects of study but as aspects of being. The unknown is not a void to be feared. It is the silence between notes that gives the melody depth. Some physicists suggest that the next revolution may come not from larger machines, but from deeper mathematics. New symmetries, new dualities, and new formulations of quantum gravity may one day reveal how space and time emerge from pure information. Already, hints of this appear in the holographic principle, the idea that the universe's three-dimensional content can be described by data encoded on a two-dimensional boundary. Such insights imply that reality is not made of matter, but of relationships, a network of entangled vibrations. To test this, researchers explore black holes, where gravity and quantum mechanics collide most dramatically. The information paradox, whether data swallowed by a black hole is truly lost, remains a central puzzle. String theory suggests that information is preserved, encoded in subtle correlations among emitted particles. If confirmed, this would mark a triumph of unitarity, the principle that nothing fundamental is ever destroyed, only transformed. Even here, though, uncertainty persists. Our mathematical descriptions work beautifully on paper, but encounter singularities when pushed to extremes. Infinity reappears like a ghost, reminding us that our current theories, for all their elegance, are incomplete. Perhaps the ultimate law will never take a final form. Because the universe itself is not finished but ongoing, improvising new variations with every quantum fluctuation. In practice, this means that science advances not by erasing ignorance, but by refining its boundaries. Each discovery pushes the frontier a little farther, yet the horizon of the unknown recedes just as swiftly. The more we learn, the more we realize how much remains hidden. Paradoxically, this endless incompleteness is what makes the pursuit of knowledge eternal. String theory, with its vast landscape of possible universes, embodies this humility. It does not claim a single, final truth, but offers a framework broad enough to contain many realities. Its equations can describe infinite configurations, yet they all arise from one principle: vibration. Thus, even within uncertainty, a thread of coherence runs, the understanding that diversity itself is the manifestation of unity. Philosophically, this mirrors ancient insights once expressed through myth and music. Where early thinkers spoke of the music of the spheres, modern physicists speak of the spectrum of fields. Both seek the same vision, an ordered harmony beneath apparent chaos. The difference is language, not essence. We now describe with tensors and metrics what poets once sang in verse. In both traditions, knowledge reaches its limit not when the equations fail, but when they reveal simplicity too profound for words. To know that everything vibrates is to glimpse a truth so complete that it transcends description. We return to silence, not from ignorance, but from understanding that the deepest reality is continuous motion, beyond separation, beyond observation. Perhaps that is why so many physicists, after years of study, speak of awe rather than mastery. To dedicate a life to deciphering the cosmos is to live perpetually at the edge of comprehension. Every solved equation opens a door to 10 unsolved mysteries. But within that unending pursuit lies peace, the peace of knowing that the journey itself is the meaning. And so the limits of knowledge become the rhythm of discovery. The mind stretches toward the infinite, understanding a little more, accepting a little less. Each insight becomes a note in the greater composition of science. Together they form not a conclusion, but a continuum, an evolving melody that leads ever closer to, yet never fully reaches, the silent heart of creation. To continue from where we left off, at the edge of understanding, one must remember that physics is not a finished book, but an evolving language. Every generation learns to speak it a little more fluently, yet the grammar of the cosmos remains unfinished. String theory, in its ambition to describe all fundamental interactions as vibrations of one underlying entity, represents the latest dialect of this eternal conversation. But the question persists. If we cannot yet confirm its predictions through direct experiment, What gives us confidence in its reality? The answer lies in mathematical consistency. A theory that unites quantum mechanics and gravity without contradiction already holds immense weight. When calculations that once diverged into infinity suddenly converge into harmony, it suggests that nature may indeed prefer this structure. In the mid-20th century, physicists realized that the traditional model of point-like particles led to infinities that could not be removed. Forces like gravity became uncontrollable at small scales, their equations exploding into meaningless values. By replacing points with one-dimensional strings, these divergences softened. The mathematics began to sing instead of scream. This internal beauty, the self-canceling elegance of the equations, remains one of string theory's greatest clues to truth. Beauty, of course, is not proof, but history reminds us that it often precedes discovery. The laws of electromagnetism, of general relativity, of quantum field theory, all were guided by symmetry and aesthetic simplicity before evidence appeared. Einstein himself once said that the most incomprehensible thing about the universe is that it is comprehensible. String theory continues that tradition, a bridge between reason and wonder. Its equations predict not a single universe but a vast landscape, perhaps an uncountable number of possible configurations, each with its own constants and dimensional shapes. Among them may exist worlds where gravity is stronger, light moves slower, or chemistry unfolds in unfamiliar ways. We inhabit one that permits stability in life, but mathematically, others could exist beyond perception. This raises profound questions about selection and meaning. If there are countless solutions, why this one? Is our universe fine-tuned by chance, by necessity, or by deeper principle? Some physicists invoke the anthropic argument, that we find ourselves here simply because this configuration allows observers to exist. Others search for hidden symmetries that might single out our universe as uniquely stable. Either way, the question itself reveals a shift, from seeking control to embracing context. In exploring such ideas, science brushes against philosophy. The boundary between explanation and interpretation becomes porous. Where once we asked, what is the universe made of, we now ask, why does it permit meaning at all? At this scale, observation and existence are intertwined. Theories become meditations on possibility. Even within physics, multiple formulations coexist. There are string field theories, worldsheet descriptions, holographic dualities, and matrix models, each offering a different window onto the same reality. Their relationships are not contradictions but harmonies in disguise. Like instruments in an orchestra, they play distinct parts that, when combined, produce coherence. This web of equivalence is one of modern theoretical physics' quiet triumphs. Among these connections, the holographic principle stands as one of the most radical. It suggests that the information describing a region of space resides not within its volume, but upon its surface, much as a three-dimensional scene can be encoded on a two-dimensional screen. If true, it implies that our perception of depth is emergent, that the universe itself may be a projection from more fundamental data. This notion arises from the study of black holes. When matter falls into one, its mass, charge, and spin alter the hole's exterior, yet all other information appears lost. However, detailed analysis of the entropy, the measure of hidden information, shows that it scales with surface area, not volume. Thus, every patch of horizon encodes bits of the world that once fell in. Reality, it seems, stores its memory on boundaries. In this light, our entire cosmos could function as a grand hologram. The three-dimensional patterns we experience may emerge from relationships imprinted on a distant, lower-dimensional boundary, perhaps at the edge of space-time itself. The celebrated correspondence between anti-de Sitter space and conformal field theory exemplifies this, a precise mathematical duality between gravity in a volume and quantum fields on its surface. Two languages, one truth. What does this mean for knowledge? It means that even our most intuitive categories, space, time, matter, may not be fundamental. They could be emergent phenomena arising from deeper informational structures. In that case, asking what reality is made of becomes less meaningful than asking how it organizes itself. The universe may be a self-coding system, a computation that forever rewrites its own rules. Such reflections extend beyond physics into epistemology, the study of how we know what we know. If reality is relational, then observation is not a passive act, but a creative one. We do not merely record the world, we participate in bringing aspects of it into expression. Each measurement is an interaction that transforms both the observer and the observed. The limits of knowledge are thus limits of interaction, not of existence. At the frontiers of quantum gravity research, scientists build toy models to test these ideas. They simulate networks of entangled qubits, the fundamental units of quantum information, to see how geometry might emerge from correlations alone. Remarkably, under certain conditions, distances, curvature, and even gravitational behavior appear spontaneously. Space, it seems, may be the collective harmony of entanglement. If so, then understanding the universe becomes akin to understanding music. Notes are meaningless in isolation. It is their relationships that create melody. Likewise, particles, fields, and forces derive identity from their interactions. The cosmos is a score written in connectivity, an ever-expanding symphony of correlation. But again, this vision remains beyond direct confirmation. We can model, infer, and calculate, but our instruments are still deaf to the faintest notes. Until we devise experiments capable of probing quantum gravity, string theory must remain a theory of potential truth, coherent, compelling, yet unverified. It occupies that strange space between science and philosophy, where imagination becomes a valid method of exploration. Still, the discipline of physics is strengthened, not weakened, by acknowledging its limits. Boundaries focus inquiry. They remind us that precision without perspective is empty. Every unanswered question becomes an invitation to refine the way we ask. In this sense, the unknown is a tool, shaping the growth of understanding. Some theorists have proposed that consciousness itself may play a role in bridging these boundaries, not as a mystical force, but as an inevitable aspect of quantum systems that include observers. If reality is fundamentally informational, and information is meaningful only when interpreted, then awareness may be the universe reflecting upon itself. Such speculation remains controversial, but it underscores how close physics now stands to questions once reserved for philosophy. Whether or not consciousness enters the equations, the search for unity continues. Mathematicians explore higher symmetries like exceptional Lie groups that might encode all known forces within a single geometric structure. In these intricate forms, beauty and logic converge. Perhaps the final law will resemble not a sentence, but a pattern, a chord that resolves every dissonance into harmony. Yet even if that ultimate symmetry is found, we will still face a mystery deeper than mathematics. Why should the universe obey any law at all? Why should reality be intelligible rather than chaotic? No experiment can answer that question. It belongs to the realm of metaphysics, yet its echo lingers in every laboratory. Science at its core is faith in reason, a quiet trust that the cosmos is worth understanding. This trust is not naive. It is an empirical pattern written into history. When we listen carefully, the universe responds with coherence. Each breakthrough, from Newton's gravity to Maxwell's fields to Einstein's relativity, revealed greater unity beneath apparent complexity. String theory extends that lineage, proposing that all variety springs from one vibration. Even if unproven, the coherence of its mathematics keeps the faith alive. And so the journey continues, through experiment, through abstraction, through imagination. New detectors will listen for primordial gravitational waves. New particle colliders may glimpse supersymmetric partners. Space-based telescopes will measure the faint polarization of ancient light. Each effort refines our ability to hear the cosmic music more clearly. But perhaps the most profound progress lies not in discovery, but in perspective. To stand before the unknown and feel wonder, rather than frustration, is itself an act of understanding. It acknowledges that knowledge is not possession, but relationship. A continuous dialogue between mind and mystery. In that dialogue, humility becomes wisdom. One might picture the future scientist not as a conqueror of nature, but as a listener, patient, receptive, attuned to subtleties. Their equations will be scores, their experiments performances, their insights harmonies briefly caught before dissolving into silence. What they study will always exceed what they know, and that excess is the very pulse of creation. Perhaps this is what the ancients intuited when they spoke of the divine harmony. They sensed that understanding does not end in certainty, but in resonance. the quiet recognition that self and cosmos are part of one continuum. Modern physics, for all its precision, circles back to the same realization. At the edge of knowledge, the scientist becomes the mystic, not through belief, but through awe. And when the instruments fall silent, when the equations rest, the universe continues its song, unmeasured, unending. We listen, we learn, and in listening we become part of the melody. The limits of knowledge are not walls but rhythms, pauses that give meaning to the music of reality. We arrive now at the quiet horizon of inquiry, the place where questions begin to dissolve into silence. At this boundary, the language of science bends toward the language of contemplation. Not because logic fails, but because reality exceeds what words can hold. String theory, for all its mathematical majesty, reminds us that understanding has a texture, woven from both clarity and mystery. Physicists once believed that with enough data, the universe could be completely decoded. Every atom, every motion, every field, all reducible to precise equations. Yet each century of progress has deepened the paradox. The more we know, the more vast the unknown becomes. Knowledge expands, but so does the horizon that surrounds it. The edge moves outward forever, like light escaping into infinite night. This does not mean failure. It means that comprehension itself is dynamic, a process of continual refinement. Each generation constructs a map, believing it to be complete, until new discoveries reveal hidden continents of possibility. Even mathematics, our most trusted compass, reveals its own limitations through paradoxes and incompleteness. No formal system can contain every truth it implies. There will always be melodies that cannot be written, though they can be heard. In this way, the universe protects its mystery. It grants glimpses, not ownership. Every law we uncover is provisional, accurate within a certain domain, yet awaiting transformation under deeper insight. Newton's laws yielded to relativity. Quantum mechanics emerged from the failures of classical certainty. String theory, too, may one day unfold into something beyond itself, a theory that listens even more closely to the music beneath form. What remains constant is the rhythm of curiosity. It beats quietly within every mind that wonders why. That rhythm drives civilization forward, through laboratories, telescopes, and equations written under midnight lamps. In each act of inquiry, the universe knows itself a little more. We are the resonance of its awareness. To understand this is to see science not as domination, but as dialogue. We ask, the cosmos replies, not always in words, but in coherence. A successful theory is not a conquest. It is a moment of harmony between thought and existence. In that harmony, both evolve. The equations change, and so do we. Mathematics remains our clearest instrument for listening to the hidden order. Its symbols are not the music itself, but the notation by which we can trace it. Through symmetry, topology, and geometry, we glimpse patterns that may be older than time. Yet we must remember that these abstractions, however perfect, are products of human cognition, translations of a melody we cannot fully hear. Beyond every calculation lies an unspoken question. What gives mathematics its power to describe reality at all? This is one of the deepest mysteries. Why should the human mind, born of stardust and chemistry, possess the ability to formulate laws that align so precisely with nature's behavior? Why does the language invented for counting also predict black holes, quantum tunneling, and gravitational waves? Perhaps the answer is that we and the cosmos are not separate. The mind is the echo of the universe contemplating itself. The logic we discover is the logic that sustains us. In contemplating the limits of knowledge, we are really tracing the boundary of identity. When we ask what can be known, we are also asking what it means to be the one who knows. Science, then, becomes a mirror as much as a method. It reflects our capacity for order, for pattern, for wonder. Each new discovery redefines what it means to be conscious in a lawful universe. This awareness carries ethical weight. To know that reality is unified, that all phenomena arise from a shared foundation of vibration, is to sense the kinship of all existence. Every atom, every photon, every living cell participates in the same underlying wave. Knowledge without humility risks dissonance. Understanding with compassion becomes harmony. Future generations may continue this symphony of inquiry. They will refine our theories, build instruments that sense deeper into the quantum sea, and uncover new mathematical languages. Perhaps they will confirm string theory's predictions or replace it with a grander framework still. Whatever emerges, it will not erase what came before, but absorb it, as each octave contains the tones beneath it. Even now, new directions appear. Quantum computing hints at universes of computation where entanglement becomes architecture. Cosmologists explore multiverse models that redefine what it means for reality to be singular. Astrophysicists search for cosmic strings, relics of primordial vibration stretched across space-time. Each effort extends the conversation between theory and observation, between idea and evidence. Yet no matter how advanced our tools become, there will always remain the horizon of unknowing. At that edge, imagination takes the place of measurement. Theorists dream in equations, drawing diagrams of unseen dimensions, guided by coherence and beauty. Some of those dreams will fail, others will transform our worldview. Failure is not error, it is feedback from reality, tuning the next attempt. Perhaps, then, the greatest lesson of string theory is not in what it proves, but in how it teaches us to think. It reminds us that reality is more fluid, more musical, than the rigid logic of classical thought. It teaches patience with complexity, reverence for symmetry, and comfort with uncertainty. These are not just scientific virtues, they are human ones. As our knowledge evolves, the questions we ask become subtler. Instead of demanding absolute truth, we learn to seek relational truth, the coherence between ideas, experiments, and experiences. We learn that meaning can exist without finality, that wonder can persist without resolution. This is the maturity of science, to replace possession with participation. And so the search continues, not toward an ending, but toward a deepening. Each new discovery adds not closure, but dimension. Knowledge expands inward as much as outward, revealing that the smallest vibrations within us mirror the largest structures of the cosmos. We study the universe, but the universe also studies itself through us. At last we arrive where words can only gesture. The scientist closes the notebook, the mathematician erases the board, the telescope cools under the night sky. Yet the universe continues. Precise, immense, unobserved, vibrating through space-time's hidden folds. It does not depend on our awareness, but it allows it. In that allowance lies grace. To know the limits of knowledge is not to despair, but to rest. Beyond the final theorem, beyond the last experiment, lies a silence that is not empty but full. It is the pause between cosmic chords, the interval in which understanding ripens into peace. In that stillness, we can finally hear what has always been playing, the quiet, endless music of existence. In the quiet at the edge of comprehension, the universe hums softly. Even now, after all the questions, after all the equations have fallen into stillness, the song continues. Every atom in your body vibrates with the same ancient rhythm that once stirred the newborn cosmos. It is the same pulse that rippled through the first sea of hydrogen and helium, the same music that sculpted stars, that breathed warmth into galaxies. You are not separate from it. You are part of that endless vibration, a note sustained through eons. Your consciousness, delicate yet vast, is a standing wave in the cosmic field, rising and falling gently within the fabric of existence. As you breathe, the rhythm of the universe flows through you. Every inhalation draws in invisible echoes from the beginning of time. Every exhalation sends them back into the vastness. The boundary between you and the cosmos softens until there is no true border, only continuity. In this stillness, matter reveals its secret. It was never solid, never rigid. It is sound frozen into structure, an ongoing performance within an ocean of fields. The electrons circling your atoms, the quarks dancing inside each proton, all of them are strings, tiny loops of vibration resonating at unimaginably high frequencies. They sing reality into being. Gravity, light, magnetism, the strong and the weak forces, all are melodies of the same instrument. Different notes, same string, different harmonics, same underlying vibration. Even space itself, that vast silence between the stars, is part of the music. It vibrates at scales beyond perception, woven by the hidden geometry of extra dimensions. The Calabi-Yau spaces curled within every point of reality act like resonant chambers, giving each particle its tone, each law its rhythm. If you could hear these harmonies, you would not hear separate notes. You would hear one vast chord, all frequencies combined into one timeless sound. Some have called it the sound of creation, others the music of the spheres. In physics, It is simply the natural vibration of existence. The equations describe it as curvature and tension, amplitude and energy. But beneath the symbols it remains a song. And every listener, every conscious being, adds their own resonance. Your awareness tunes the field slightly, ever so slightly, shifting the universal melody by existing. You are not an observer outside the orchestra, you are one of its instruments. When you close your eyes, the universe does not disappear. It folds gently inward. Your thoughts become ripples in that same invisible sea. Each memory, each dream, each heartbeat echoes through the fields like faint light through crystal. You are an interference pattern of awareness, a vibration perceiving vibration, a string listening to its own sound. Through you, the cosmos becomes aware of its own music. It listens to itself and smiles, a wave recognizing another wave. And in that reflection, consciousness emerges. M-theory whispers of 11 dimensions, layers of space folded beyond sight. In some of those higher dimensions, other brains may float beside ours, parallel universes drifting silently through the bulk. Some may be close enough that their gravity tugs faintly on ours. Some may be as distant as forgotten dreams, but all of them hum with the same underlying tone, one fabric, many surfaces. The strings vibrate through them all, unseen but eternal. Every possible universe, every possible history, is another harmony within the grand composition, each with its own instruments, its own tempo, its own subtle meaning, yet all connected by the same mathematical rhythm. Perhaps this is what the M in M-theory truly means, not just mother or mystery, but music, the melody that holds space and time together, the vibration that becomes both gravity and thought. And just as all melodies eventually resolve, all vibrations settle into quiet, not an end, but a rest, the silence after the final chord, the pause that gives meaning to the song. In this silence you can feel it, the faint shimmer beneath nothingness, the zero-point hum that never ceases. Even the vacuum is not empty. It quivers with latent possibility, a quiet ocean of energy waiting to express itself again. Physicists call it the quantum field, philosophers might call it the breath of creation. But to the sleeping mind, it is simply peace. The peace that comes from realizing that even when all appears still, the music remains. You are surrounded by that sound now, not in your ears, but in the foundation of what you are. Every cell, every photon, every thought hums softly within it, the lullaby of existence. Let yourself drift deeper into that rhythm. The body grows lighter, the thoughts drift slower, until all distinctions dissolve. You are not here or there, not past or future, only vibration, only resonance, only the song. Beyond galaxies, beyond atoms, beyond the idea of self, there is only motion within stillness. Every universe expands, contracts, breathes like a note that swells and fades within the infinite score. To sleep is to align with that rhythm, to rest in the same pulse that guides the stars. To surrender into it is not to lose awareness, but to merge with it, to become what you always were, one tone within the harmony of all things. Somewhere beyond perception, the strings continue to sing. Their tones weave the tapestry of matter and mind alike. And long after your conscious thought drifts into dreams, their music carries on. It carries you, effortlessly, cradled by vibration, wrapped in the quiet rhythm of creation itself. The universe breathes through you one final time tonight, and as your awareness dissolves into the stillness, you become part of that eternal harmony. The strings are still singing, they always will, forever and ever,